Hello, everyone. My name is Raj Dutt, and I'm one of the co-founders and the CEO here at Grafana Labs. It's my pleasure to welcome you all to ObservabilityCon 2021. Really great to see so many thousands of registrations from all over the world. So this year's ObservabilityCon is all about the journey. Now, it's certainly been a journey for all of us here at Grafana Labs, particularly over the last year and a half, and I'm sure it's been for each and every one of you also in many different ways. On the personal journey, even though we like to say we're post-geographical at Grafana Labs and location doesn't matter, being a remote-first company, It's really good to be back home in New York City. It's hard to believe that I was camped out in Singapore for over a year. Thanks to Zoom, thanks to working vampire hours, and thanks to asynchronous remote-first environment, I didn't really miss a beat, but it's good to be home. On the Grafana Labs journey, things have really progressed quite considerably since the last Observability Con, and since the last Grafana Con and release of Grafana 8 earlier this year. We're now well over 500 employees around the world, and we recently celebrated our 7th birthday. A few months ago, we also raised a new round of financing from Sequoia and Co2. Our existing investors also participated in this round. We raised a total of $220 million at a $3 billion valuation. If I go back to when we started 7 years ago, that seems like an insane amount of money. And it is, but I have to consider it an indication of two things. It's a vote of confidence on what we've accomplished as a team and what we still have, the potential of things that we can still do. And it's also an indication of the support from all of you, our customers and our users. So a big thanks to both the extremely talented Grafana Labs team that I have the pleasure with of working every day, as well as all of you for helping us get to this incredible milestone. So getting more specific on journeys, the tagline for this year's Observability Con is, "Observability is a journey, not a destination." What do we mean by that? Well, we live and breathe this concept at Grafana Labs. It permeates our products and our strategy. We really believe that observability is a journey, and it should be about your journey, your strategy. It's a journey that you should control and be in charge of. Our view on this is quite different than most companies. But then again, we never claim to be like most companies. Grafana Labs is all about flexibility and choice. We're all about meeting you wherever you are in your journey. We prioritize interoperability and composability. We offer you flexibility and choice in your decisions about where your data is stored. Want to use Elastic for logs? Fine. Loki for logs? Fine. Prometheus for metrics? Great. InfluxDB for metrics? Great. The choice is yours, and Grafana can help you bring all your data together beautifully. We want to help amplify your existing IT investments. Now, being able to visualize, transform, and alert on all your data, no matter where it lives, is a key part of what we're all about. We don't require or expect you to consolidate your data into our backend or any one backend. We realize that your teams are using different tools, open source projects, commercial vendors, and cloud providers. Now, this focus on interoperability and composability, this flexibility, is what our big tent strategy is all about. It's a metaphor for how we view the ecosystem. There are now over 115 data source plugins for Grafana. We have dozens of data source plugin partner companies like Influx Data, ClickHouse, Sentry, Elastic. They all collaborate with us to bring the best possible experience for their backends to Grafana users. You shouldn't have to switch between all these different tools, point fingers at different teams, or have to do a rip and replace. One of the oldest lies in IT is the promise of a single pane of glass. More often than not, it turns out to be a single glass of pain. We think that the big tent is a better way forward. So I'd like to make an announcement about a new guest, a new very welcome guest in the big tent, a major player in the Grafana ecosystem, Microsoft. I'm really thrilled about this announcement. The teams have been working on this for months, and it's been a real pleasure building on our relationship with Microsoft that started a few years ago, back in 2019, with a plugin partner on the Azure Monitor Grafana data source. So today, we're announcing a first-party Grafana service on Azure, and this is a collaboration between Microsoft and Grafana Labs. There are many Grafana users who have a footprint on Azure, and this partnership makes it easy for Grafana users to get a fully managed Grafana service from Azure, from Microsoft, utilizing their existing relationships, spend commits, and custom pricing. It's back to the flexibility point, meeting our customers where they are and where they're going on their journey. Customers will be able to spin up their own Grafana instances and also seamlessly upgrade to Grafana Enterprise, all on one of the most exciting clouds in the industry. So welcome, Microsoft, And it's really great to see that we have partners with Amazon, with Microsoft, Google, Tencent, Alibaba. We're really focused on meeting you wherever you are. So again, welcome to ObservabilityCon. We've got 2 days of great content from over 40 speakers, not just about Grafana, but about the wider ecosystem, the big tent, and we hope we can help guide you through your journey. Thanks, everyone. Over to Tom to tell you more about some of the exciting things that we've been up to.
Thank you, Raj. Today I'd like to talk about three things. I'd like to talk about the LGTM vision. This is the ability to combine metrics, logs, and traces into a single platform. I want to talk about what Big Tent means for our database projects, so for Cortex, for Loki, for Tempo. And I want to talk about how Grafana Cloud has developed over the past year and how it's so much more. About 3 years ago, we presented this picture of observability. A lot of our customers want to compose together their own choice of tools, and this leads to problems of discoverability, of translating queries between different tools, and of manually propagating the state you build up as you investigate an issue. This made incident response slow and error-prone. We set out to solve this, and over the past few years, we've incorporated logs and traces into Grafana so that you can really own your own observability strategy. You can combine your choice of tools but keep a single consistent experience, and you can seamlessly move between metrics, logs, and traces. We think this saves time, this reduces stress, and generally reduces your mean time to response. I think this is a pretty linear model, and it's really actually quite far off what the world needs. So I want to talk about a new model. We actually presented this model in the keynote in 2019 at KubeCon. This is a more flexible approach, a debugging workflow that really allows you to go back and forth between these different sources. And today I want to talk about the progress we've made towards this. So first off, you should all be pretty familiar with this. In Grafana 6, 2 years ago, and Loki 1.0, we showed you how you could find logs from your metrics quickly and easily. Loki's logs are systematically labeled the same as your metrics using Prometheus Service Discovery. And this guarantees you can always find those logs given any graph. This technique really reduces the amount of time it takes to get to the root cause of a problem and reduces the stress of being on call. We use this every day. In Grafana 7 a year ago, we launched the ability to link log fields to traces, right? Making it easier to find the trace for a given log line. This really helps you go from that zoomed in context of a single log for a single service to that big picture, to perhaps see where latency was introduced by other services. Traces are great for debugging performance issues, and we think this really kind of completed phase 1 of LGTM. So then last year in Loki 2.0, we added LogQL. This is our Prometheus-inspired query language that allows you to extract metrics from your logs. Being based on PromQL, users who are already familiar with that language took to this really quickly and found it incredibly easy to extract metrics, potentially from systems that are uninstrumented or a legacy. In Grafana 8, more recently, we launched support for exemplars. So these are allowing you to link directly from your metrics to your traces, and we think this is a first for an open source project. This allows you to really shortcut that metrics to logs to traces flow. And when it comes to debugging slow requests, we think this just saves huge amounts of time. And finally, with Tempo, we built the ability to link between traces and logs using the same trick we do as Loki. We consistently label the spans with the same with the same labels you label your logs with. This often helps you find the context, perhaps when you're looking at an anomalously long span. The logs will tell you what's going on in that service at the same time that might have contributed to that latency. And that pretty much takes us up to date. We've been calling this the LGTM strategy, and so far these experiences have worked best with our opinionated stack, with Grafana, with Prometheus, with Loki, and Tempo. Our mission at the moment is to expand these workflows to other data sources, to Graphite, to Elastic, to Jaeger. We're using a technology called Grafana Glue to really expand this support. Next, I want to talk about Big Tent for our database projects. Raj talked about Big Tent earlier, but what I find interesting is there was always a bit of a contradiction at Grafana Labs. On one hand, Grafana embraced Big Tent and supports over 100 data sources, but on the other hand, we had a slew of database projects which were somewhat opinionated and designed to all integrate together seamlessly. And so I really want to talk about how we're bringing this Big Tent philosophy to those backend projects, and in particular to Cortex and to Grafana Enterprise Metrics. So it's actually always been the case that we've had two horizontally scalable distributed metrics databases at Grafana Labs. We've had Cortex, the scalable Prometheus database, a CNCF project that I've worked on for many, many years. And we've had Metric Tank, our scalable graphite database. They're both written in Go, but they take very, very different approaches to architectures, and having both has allowed us to learn the best of both worlds. So about a year ago, we launched the Grafana Enterprise Metrics project, and this combines learnings from both of these projects. This allows you to query Prometheus metrics using PromQL, graphite metrics using the graphite query language, or vice versa. You can query Prometheus metrics using graphite, or graphite metrics using Prometheus. We use Grafana Enterprise Metrics to offer Grafana Cloud, and we found this as a capability has really helped users migrate from graphite to Prometheus. About a month ago on our blog, we announced the ability for customers to ingest metrics from the Datadog agent into both Grafana Enterprise Metrics and Grafana Cloud. You can configure the Datadog agent to send the metrics to us, and we'll seamlessly translate those API calls into Prometheus metrics and store them. This is something a lot of our customers asked for, and it really helps them combine their Datadog, Prometheus, and Grafana into their observability strategy. But we didn't stop there. We also launched the ability to translate exported Datadog dashboards into Grafana dashboards, again helping users combine these technologies and helping users in a single Grafana instance use both Datadog and Prometheus metrics. And finally, we also launched the ability to translate a subset of the Datadog query language into PromQL. So this allows you on the fly to run a Datadog dashboard against our GEM or Grafana Cloud backend, and means you can write queries in Datadog QL and have them executed against GEM and against Grafana Cloud. So if your team already knows how to use Datadog, they can use Grafana Cloud. The GEM project and Grafana Cloud combines all three of these technologies, making it available both in cloud and self-managed on-premise environments. I think this is pretty unique and pretty exciting. And it's also pretty cool to kind of parse and translate different query languages, and you really learn about the strengths and weaknesses of each one. Finally, I'd like to talk to you about Grafana Cloud and how Grafana Cloud is so much more than just metrics, logs, and traces. We've really spent the last 18 months making Grafana Cloud the easiest and quickest way to use Grafana, Prometheus, Loki, and Tempo together. And I want to talk a bit about how we've done that. So first off, we actually built this project a couple of years ago, and we've talked about it many times, but synthetic monitoring is really the start of this journey for us. We built an opinionated service off of open source technology. So we used the Prometheus black box exporter, we used Cortex and Grafana, and we assemble them together into an easy to use system that basically means you just have to put in the address of your website and we'll hit it from many locations around the world, and you can see the reachability and response times from those locations. It means you don't have to deploy and manage black box exporter on many, many providers and many, many clusters. Then about a year ago, we first launched what we've been calling integrations. So this is the packaging together of alerts, of dashboards, and of the exporter and metrics translation pieces into easy to consume little bundles. We've built over 40 of these, and you can come along and, as part of the sign-up flow for Grafana Cloud, say, I want to monitor my MySQL. And it gives you some really simple instructions to get the metrics out of your MySQL really, really quickly. We've built these exporters into the Grafana agent, and really the Grafana agent is key here to making this possible. The Grafana agent packages together the Prometheus agent, it packages together Promtail, the Loki agent, and OpenTelemetry, all into a single, easy to deploy binary, giving you one thing to manage alongside all of the exporters that we embed into there. The latest development is what we've started to call internally our agentless integrations. The first of which is one for AWS CloudWatch. So you follow a series of simple instructions, and it allows us to gather metrics on your behalf, meaning you don't have to run an agent, you don't have to run any infrastructure, and we can get the metrics out of your AWS account into Grafana Cloud for you to combine with your other metrics you store in Grafana Cloud. And then finally, we want to talk about Kubernetes. Grafana and Prometheus have become the de facto standard for monitoring Kubernetes, and we wanted to make this as easy as possible for users to get started with and use. So we've built a kind of Uber integration for Kubernetes that makes sure you're always running the latest version of the dashboards and of the agent and so on. It gives you a single thing to install to collect metrics, logs, and traces inside your Kubernetes cluster, and really allows you to not only observe the cluster infrastructure, but also your application and its resource usages within the Kubernetes cluster. So this is really exciting, right? Grafana Cloud is more than just metrics, logs, and traces. We've built and continue to build a ton of easy to use, valuable services on top of those core telemetry systems. And our aim is very much to make Grafana Cloud the easiest and quickest way to get started using Grafana, Prometheus, Loki, and Tempo. And there's a lot of empty boxes here because the most exciting things are really to come, and I can't wait to tell you about them at next year's ObsCON. So thank you for listening. That's really the end of my little section. A brief summary. I talked about how we evolved the LGTM vision, making your experience with metrics, logs, and traces even more joined up, and how we've taken this to more than just Prometheus, Loki, and Tempo. I talked about how we're bringing the big tent philosophy to our database projects and to Gem and to Grafana Cloud. And then I talked about how Grafana Cloud is so much more than just a hosted telemetry stack, and how it's becoming the easiest to use observability platform out there, all built using the best open source projects. So if you like what you've heard here today, go to these talks to see more and get more details and see some demos. We'll also cover some of the improvements we've made to the core platform, to Cortex and so on. But now I'm going to hand over to Jen for some exciting news about Loki and Tempo. Thank you.
All right, thanks, Tom. I got a lot to cover, so I'm just going to dive right in. First up, I'm thrilled to announce that we have a new release for Loki, Grafana Labs' log aggregation system. There's a ton of improvements coming in 2.4, but above all, I'm excited to highlight a new deployment option that should make Loki easier to use than ever before. Now, to set the stage for why we did this, let's go back to a typical user experience when they get started with Loki. Day one Loki, it's super simple. With the single process deployment option, you download a single binary, single Loki local config, and with one command, boom, you're off to the races. You start playing around with Loki, throwing logs at it and querying it back, and you're thinking to yourself like, geez, this is great. I like the label model and how it's consistent with Prometheus. I love the live tailing. I love creating metrics from logs, and I love how easy it makes it to centralize logs coming in from all over the place. So you start thinking to yourself like, hey, this went awesome. I want to be able to do this at my organization. Well, okay, what are you going to need to be able to do that? One, you're going to need to be able to scale this up to handle the log volume at your company. Two, you're going to be able to need to provide consistent observability for querying and writing logs. Three, you're going to want a slightly more durable form of storage than just local disk, which the single binary uses by default because you don't want your logs to get lost. So, okay, cool. You go to the Loki docs, you start hunting around in there, and you're presented with this. Okay, just, set up Loki and microservices is our answer. I mean, that's what we do at Grafana Labs. Unfortunately, though, this is pretty intimidating. You've got 12 services to configure and manage, each which needs to be scaled independently, and each of which has its own configuration. I mean, sure, deployment tooling can help make this easier, but a lot of that tooling out there is focused on Kubernetes. So if you're on VMs, bare metal, Nomad, Mesos, or anything else, you're pretty much out of luck. So the jump from that single process mode I started with, which isn't fit for a production environment, to that microservices deploy I showed, it's daunting. And depending on your infrastructure, it's not even feasible. So we thought to ourselves, how could we make Loki easier to run in a production environment without that big complexity increase you get from going to full-on microservices? How could we keep people from giving up on Loki after that amazing day one experience? Well, we spent the last 3 months thinking about it, and what we've come up with is an intermediate step on your journey with Loki It fits perfectly in between the single process mode and the full out microservices mode. Now you can deploy Loki as read and write nodes, where we bundle all the read services together in one process and all the write services together in another. It's going to give you scalability and high availability. You need to send more queries? Just add more copies of read. You need to send more log volume? Add more copies of write. And along the way, we've shrunk the size of the config file you're going to need to do this by 70%. So you don't have to wade through hundreds of lines of config to figure out how it all works. Now, okay, maybe you're a Kubernetes whiz or your Loki setup, it's already pretty optimized. Even then, Loki 2.4 has some really neat upgrades for you too. So one of them is a ton of improvements coming in the log panel, including pagination, log details, and more powerful templating. Loki 2.4 also has major upgrades to making it easier to delete logs. This is something that's really important for users who have to be able to manage privacy and right to be forgotten requirements. So what do we have? We now have an API for targeted deletion of streams based on label matchers. So boom, one command, stream gone. And we also now have the ability to define log retention policies at both a per tenant and a per log stream level. Lastly, you spoke and we delivered. Loki 2.4 will give you out-of-order logs, something that we've been frequently asked for by our community, and we're proud to be able to say we finally built. So here it is, Loki 2.4, a simpler read-write deployment model, improvements to the log panel, better deletes, and out-of-order logs. Whew, taking a deep breath here and switching gears to traces. I'm really excited to announce the release of Tempo 1.2, our distributed tracing backend. Now we've got a really cool session coming up later in the conference where we'll deep dive into these new features. But let me just give you a tiny preview of what you got coming. Now, to date, Tempo users have had to rely on metrics and logs as a way to find the trace IDs they want to inspect. But we've heard time and time again from the community that what they really needed was native search, the ability to find traces directly from within Tempo using tags and other metadata. So we listened, and after a lot of hard work and some elbow grease, we are excited to tell you that Tempo 1.2 is our first release with native search. We've been running it a couple months already in our environments, and we're really excited about what we see. We've also made significant improvements to Tempo's service graphs. What are service graphs? Well, they're visualizations that help you understand the topology of your system as well as the flow of information between different services. They'll help give you a clear picture of what's going on and where the bottlenecks exist. So, in addition to those great announcements that we have on the open source front, there's one other tracing thing I have for you. Going back earlier this year in June, we released Grafana Cloud Traces based on Tempo as part of our fully managed cloud observability stack. But for those who weren't able to use a SaaS solution and still needed the feature set of a large enterprise, we didn't have an option for you. Until now. We're releasing Grafana Enterprise Traces 1.0, the last piece of the Grafana Enterprise stack. So in the same way that our enterprise metrics and enterprise logs products take everything you love about Cortex and Loki and turn them into products that you could run in a large organization, we've done the same with Tempo and Grafana Enterprise Traces. So what does that mean? It means Get is built on top of Tempo, which means users get all the great features of Tempo, including the ones I just talked about, plus all the features that you'd need to satisfy the requirements of a large enterprise. As a refresher, let's talk a little bit. What are those pieces that a large enterprise cares about? Well, this is something we have plenty of experience with from running our own cloud service internally. So let's start with the first one. When you're providing observability as a service in your organization, the only way you're actually going to be able to scale that effectively is with a multi-tenant system. How does that work? You run one or a small handful of Tempo clusters, but you give each team its own slice of the cluster. Now, Jet is going to build on the great multi-tenant functionality in Tempo and make it easy for you to create new tenants, edit them, delete them, set limits for them so they don't interfere with one another, and at the same time, really just give each team the experience of having their own dedicated tracing backend. Security and access controls, another thing that large enterprises care about, because traces, they can contain sensitive information. So how do you ensure that the right set of people have access to the right data? How do you think about what that access should look like? Should it be read, write, administrative, deletion? Jet's going to ship with native authentication support, the ability to create and delete and edit fine-grained access policies, and the ability to integrate with your existing authentication systems like OpenID Connect. Lastly, simplified administration. Oftentimes, you really end up having one small observability team that's tasked with supporting a massive developer organization. So how do you give them the tooling they need to even make that possible without having to quadruple or quintuple the size of your observability team? Well, Jet's going to help you with that. It's going to give you APIs and a dedicated Grafana administrative plugin to let you modify and configure your cluster as needed and get a quick view into the state of the cluster at any time. Lastly, what's great about Grafana Enterprise Traces is that it's supported by the experts who develop Tempo. You can rest easy knowing that if something goes wrong, you've got the maintainer team at your back. Grafana Enterprise Traces is completely compatible with Tempo, which means you can just drop in the Jet binary in place of the Tempo one, and off you go. Taking a step back to look at the global picture, the release of Grafana Enterprise Traces is really meaningful to us because it completes a journey that we started way back in 2018 with the release of Grafana Enterprise. With Enterprise Traces going live, we can now say that we offer a complete observability stack with all the features it needs to be enterprise ready so that enterprises can offer observability as a service on their own infrastructure. It's one stack that does everything for you. It gives you everything you need to understand software systems at your organization. That's both easy to deploy and manage as one. If you want to learn more about the upcoming Loki, Tempo, and Enterprise Traces releases that I just talked about, be sure to check out one of these two sessions. That's all for me, and I'm going to pass the mic to Nicole to talk about load testing and K6.
Hi everyone, I'm Nicole van der Hoeven and I'm a developer advocate at K6. K6 joined the Grafana Labs family in mid-June earlier this year, and most of the K6 team watched with bated breath while Raj Dutt announced the acquisition at Grafana Online. We all celebrated together, albeit virtually. We've been using Grafana for years, and they've been using K6 for years, so it made perfect sense to us. But maybe it doesn't make sense to you, at least not yet. So let me tell you about K6. We have two main products at K6. There's K6 OSS and K6 Cloud. K6 OSS is an open source load testing tool that's built with the developer experience in mind. It's free to use, and a single instance of it can generate tens of thousands of users. Now, K6 Cloud is a SaaS platform built around the same tool, but it adds distributed cloud execution options, a graphical test builder, performance insights, real-time results, team collaboration, and many more features. Both products are good at turning a load test into actually actionable data and assessing applications' performance at every step of the development cycle. But what does that have to do with Grafana? K6 already integrates with Grafana today in two different ways. First, there's the K6 Cloud Grafana Data Source plugin. Installing this plugin lets you pull in data from your K6 Cloud account, bringing in all of your past load test results. This is best if you want to recreate the experience on K6 Cloud, but in Grafana. You do need a K6 Cloud account, but it works with any instance of Grafana, whether it's Grafana Cloud, a locally hosted Grafana instance, or Grafana within a Kubernetes cluster in the cloud. Secondly, there's Prometheus Remote Rate. This integration lets you treat your load testing results just like any other metrics, and is particularly handy if you're already using Prometheus in your stack. This works with both K6 Cloud and K6 OSS, and with any instance of Prometheus. Now let me show you what K6 OSS looks like. K6 is written in Go, but the scripting language is JavaScript, which makes it really easy for developers and testers to get started. This is an example of a simple K6 script. Right now I'm just running it for 5 minutes with 5 virtual users. It makes one GET request, and then it verifies that the response that's returned has an HTTP 200 status code, and it also looks for the word Pikachu in the response. And this is a pause to simulate think time. To run it, you can use the K6 CLI. So to do that, you would just type K6 run and then the file name. And then it starts running. You can see that the execution mode here is local, and that's because this is just running on my machine right now. I'm not actually going to let it run through. I'm going to stop it early. And this is what the results will look like. You'll see whether those checks have passed or failed, and you'll see a lot of metrics about the mini test that we just ran. Of particular note would be the HTTP rec duration, which is like the response time. We see here that it is just under 1 second on average. Now, what if we want to take this even further? Because this is just running locally right now. Well, let's look at this script. It is the same one, except that I have added these parameters here in options. What this is doing is it is setting up Prometheus Remote Write as a way to get those load testing results into an instance of Prometheus. In this case, I'm using Grafana Cloud. So let me show you how to get those credentials. From your Grafana Cloud account, you can just go to Prometheus here and click Details. And then you'll see the remote write endpoint URL. You will need that, so you would copy that. You'd copy your username, and you would click Generate Now and copy that API key as your password. And then you put all of those things into the script here. And this time, when we run it, I'd like for those results to be visualized in Grafana. So I'm still running it I'm still firing it off from my CLI locally, but I'd like to run it on the K6 Cloud. To do that, it's a slight change in the command. So instead of K6 run, I'm now going to do K6 Cloud. And then this is the name of the revised script with the Prometheus details. And I'm going to start running that. Now we can see that this is uploading the archive, which includes the test file, the actual script, and a copy of K6 that will be started on on an AWS instance that we are provisioning. You'll also see that the execution here has switched to cloud. So I'm starting it off on the CLI, but it's actually running on our AWS account. Now we can go ahead and have a look at this on K6 Cloud to see what it looks like there. Now K6 Cloud does have shareable links, so if you toggle that on, you can share this link to somebody that's on your team, so they don't have to necessarily have a K6 Cloud account to be able to monitor your test with you. And this is our test. It looks like it has started a load generator in Ashburn, which is also something you can configure within the script. And it's going to be running for the next 5.5 minutes because of the ramp up period. So on K6 Cloud, we do see a bunch of other metrics here that's presented in a nice visual interface. If we had any thresholds, we would see it on this tab. We can see the checks that we do have set up and the success rate for those checks. We can even create custom dashboards by adding metrics that we want to display here. And of course, we can see the HTTP requests and some statistics about the response time. But we wanted to see it on Grafana Cloud, right? So let's go and have a look at that. This is a test that I ran previously, but I would like to see one that's running right now. So I'll head to see the last 5 minutes, and this is our test. I can see that we already have the 5 virtual users all ramped up and going. The response time right now is 1.63 seconds. And we are seeing a lot of these metrics that are going from the K6 script that is running on the cloud. So now we have these 2 ways of seeing it. First is on K6 Cloud, and the second is in Grafana. Both are really useful, and I think that it's a good idea to have them side by side. And I think that being able to pipe those results out to Grafana make it even better, because that's putting those load testing results into a tool that maybe your site reliability engineers or performance engineers are already looking for server-side metrics. So that's K6. I hope you enjoyed that sneak peek of K6's capabilities, and maybe you understand now a little bit more why K6 and Grafana make a lot of sense together. Observability and incident and response management are often reactive in nature. They show you what's happening right now. Testing and K6 allow you to be more proactive, seeing how your application behaves even earlier in the development cycle. The combination of K6 and Grafana helps you build confidence in your application's behavior in both production and pre-production environments. And K6 and Grafana also have compatible open source philosophies, composable tools, and great engineers on each side who love using each other's tools. We are really excited to be part of Grafana Labs, and we're eager to show you what we're working on. I'd like to invite you to join our talk later today, where I, together with my colleagues CEO Robin Gustafsson and software engineer Olha Yevtushenko, are going to dig deeper into K6 and also announce something new. Because remember when I said that K6 was a load testing tool? Well, that's still true, but we're expanding that definition, and soon. Come to our talk later to find out more.
Thank you, Nicole. I'm really looking forward to that announcement. So, it's me again, and I've always wanted to do this, but we have one more thing to talk about. And it's my pleasure and my privilege to announce that Grafana Labs has acquired Amixer, a company who has spent the last 3 years working on incident response. I'd like to introduce you to Matvey and Ildar, the founders of Amixer, who themselves have a pretty exciting announcement to make.
Thank you, Tom. It was an amazing journey, and I'm so proud of joining the team. Even before acquisition, we've been huge fans of Grafana products and the open source culture. That's why the decision of joining was really easy to make. There are a lot of people who made it possible. I want to say thank you to the rest of Amixer team, our investors, and of course, customers. Today, we launched a public preview beta of Grafana On Call in Grafana Cloud. Let me talk about the product a bit. Grafana On Call. We've built it to address our own pain of being on call. Waking up in the middle of night because of incidents, keeping infrastructure up and running is stressful and responsible job.
Our mission since the beginning was to make on-call less stressful for folks like us, and today we became a bit closer to it. A lot of people use Grafana, Alert Manager, even other monitoring systems, and they generate a lot of useful infrastructure signals. But engineers, they don't usually like to dig through all those signals at 3 AM in the night and check if that's an outage or not. Here is where Grafana On Call helps. Basically, it's the hub for those infrastructure signals. It converts those signals into meaningful incidents and pages the right people in the right time in the most comfortable way. It groups alerts into incidents. It routes them to the different teams using different escalations. It brings the context to the incident, tells you when it started, who else was invited, what the planned escalations are. It provides a way to set up on-call shifts using the tools engineers actually like. I'll be giving a demo later today. Please come see it. Thank you. The next session will be, actually it's going to be us again. Dee, Matvey, and me, we will be talking about Grafana alerting and Grafana on call, answering all your questions on the Q&A session afterwards. Thank you for joining us today on the keynote. Please join our Slack channel and our community.
Hello, welcome to the ObservabilityCon session on Grafana alerting and Grafana on call. I'm Dee, and in about 10 minutes time, I'm going to be joined by Ildar, who's going to talk about Grafana on call. And in about half hour's time, Matvey is going to join us for a Q&A. But I'm going to be talking about Grafana alerting. Now, everything in your business generates data, everything. We're used to thinking that it's just systems, but it's also the line of business apps. It's sort of e-commerce systems. It's Salesforce. Everything that you do, everything that any of your staff does, generates data. And we want to be able to alert on that. Now, prior to Grafana 8 and the latest versions of Grafana Cloud, if you wanted to alert on this, you had to pick different tools. You would choose Grafana for some of your line of business data. You would choose Prometheus for some of your system stuff, and perhaps you'd choose Cortex and Loki when you needed additional scale or to alert on your logs as well as your metrics. In Grafana, we used to be able to sort of seeing all of your data from everywhere. So it was a little bit weird that we couldn't actually see and manage your alerts from everywhere. And it's a bit weird that we had this one tool that if an alert fired and it was Prometheus alert, the tool that you'd then turn to as an engineer would be Grafana. So what we've done, we've actually improved Grafana alerting in such a way that now inside Grafana Cloud, inside Grafana 8, you can actually write an alert based on many different data sources. You already had that, but now it actually brings them all together in one place. You could write multi-data source alerts. You didn't have that before. And multi-dimensional alerts inside Grafana as well, whereas before you would have had to write one alert per panel. Now, what this means is that we have the single pane of glass for alerting. We've got it for the actual visualization, and now we've got it for alerting too. And I'm going to show you that today. So that's the demo. This is Grafana Cloud, and you can sign up. You can do this right now. You can sign up, you can use Grafana Cloud, you can try it out, and you'll be able to access this. Now, I've only done a simple thing. I've added a couple of machines that I've got to node exporter. It's Prometheus node exporter. It exposes metrics about key system data. And I've just said, from a load balancer, one of the API servers, one of the Python servers, bring up the actual CPU load. And I'm surfacing it here as a percentage out of 100. So you can see that these machines are not particularly busy. They're barely 20% of use of their CPU. And this one here is, well, actually, it's really more like 5-6%. And we want to alert on that. That's something you could have done. In Grafana, you would have had to write 3 alerts. In Prometheus, it's just 1 alert, and it's really, really simple, and you already could have done that. But I want to show you why Grafana alerting makes this better. Now, if you're up here on Grafana Cloud and you go over there, and down the left-hand side, you'll see the little bell, which is the alerting. This is there in Grafana OSS. It's there in Grafana Cloud. It's easy to find. And when we click on that, you'll see that I've already set up some alerts. Now, what I want to show you is one of the alerts I've set up, which is high CPU load, important customers, because we can really sort of sit down and say, are all of our alerts equal? Are all of our servers equal? What would it take to actually write an alert where we say some of our systems generate more revenue than the rest of our systems, and we should be more sensitive? We should apply different thresholds to those systems, and instead of waiting for something to go wrong, we could be more preemptive. But that's only valuable in those systems where we have really high revenue, and that's because we have important customers. And you can see that you'd have other criteria for that as well. It doesn't have to just be important customers. You could just have a more critical system, and you might have traditionally written sort of separate alerts, but I'm going to show you why you don't need to do that anymore. So let's edit this one alert, high CPU load. This is a Grafana managed alert. You can still write a Cortex, a Loki, a Prometheus alert, and a recording rule, but we're going for a Grafana managed alert. Now, these are based on server-side expressions, and if you use Grafana 7, you've already seen these. The panels had the capability to run several different sort of queries, different data sources, and they would be executed on the server. We're now taking that and we're implementing that within the alerting system. So the evaluation happens on the server, and we can do more powerful things. Now, I'd still have the Prometheus alert. Prometheus PromQL sort of expression to fetch the actual CPU load. And here you can see, as soon as I've touched it, it's come alive, and I've got my 3 little lines representing my 3 servers. And if I click stat, it's going to show me really what's going on here. So my API server is 22% CPU load, and that's my graph over time. My load balancer, it's a lovely little saying, it's just we're ticking over at 6%, and my Python machine at 1920. Now, this next stage is interesting, and this is in Grafana alerting, and this is what makes it very different from the prior version of Grafana. We can now take these numbers and perform a reduce over them, and typically, historically, it would have been a classic condition. It would just take the last of the numbers and apply one instance, hence you had to create multiple rules. But here under the reduce, we can actually flatten these to an average. So here I've got the mean of the CPU load there, 22.8, the mean there, 6.36. Now, what you need to note here is the input CPU load. This is a named query. In fact, out of the box, it's just called A. And, I call it A. There. But I like to name them something useful. So I'm going to call it CPU load. And let's go back and put that back in as well. So now I've got my CPU load for these 3 machines. But I did say that not all of these machines are equally important. Some of these machines are more important. In fact, I only want to alert 2 of these machines. So I'm going to combine another data source, and this is Postgres. Now, in Postgres here, I'm using Postgres, but you can use MySQL, you can use whatever admin database you've got, you can use Salesforce, can tell you directly from the actual sort of sales figures, these are our important customers. And there would obviously be some map to which machines host the more important customers, or whatever your criteria of important are. And that's what I've got here. I've really just got a map, the idea that these machines, it's just these 2 machines. So we're forgetting the API one, this one here, and we're focusing down on these 2 machines here. These are the important ones. And I currently got the thresholds at 50. But what if I said the thresholds, one of them was going to be 10, the load balancer, and the other one was going to be 15, the Python machine. Now, you should be able to see that that means that this one should not alert, and that one is going to alert. So this is now showing the result of that query, and it's showing our thresholds. So our thresholds here are coming from data. They're data-driven. The final part of this magic is this. This is an expression. Everything else before here was a query, but this step is an expression. And the expression here is taking mean CPU load. That is our named query. That's it there. And it's saying where the mean CPU load is above the important customer thresholds, another named query. That produces the alert criteria. And if I show you that, then the load balancer is not alerting. Its CPU was 6 and the threshold is 10. And the Python machine is alerting. Its CPU was, I think it was 19. And I've set the threshold to 15. So that's generating our alert. This magic is a natural join. So if you know SQL, you know what a natural join is. And it's doing it based on the label. That's the same as that label, and it's the Prometheus instance. So it's a natural join. Now, with that all done, we can define our alert. Our alert here is going to fire based on CPU over threshold, named expression. And when we preview this, it does exactly what we think it should do. So we now have an alert that's only going to apply to a subset of our machines that is data-driven, and it's deriving the threshold based on our data-driven values. Now, we've stored that in Postgres, but you could store it in whatever system you already have that has this line of business data, because we can easily join up on those other things as well. The last part of this UI, really, it's just some additional work. These things here, they're actually just key value pairs that result in the content of the alert being customized and shown to you. And the labels at the bottom here, these are used as part of routing logic. And I'm very quickly going to touch upon that. So if we save that, that alert is now going to work. And if we were using the notification policies, you can see that actually different teams would receive different sort of emails and sensitivities. And that is a very quick dip into Grafana alerting in Grafana Cloud and Grafana 8. And with that, I'm going to go back and hand over to Ilda, who's now going to tell you about Grafana OnCall. Thank you.
Hi again. Thank you, Dee. Great demo. I'm so excited about new, much more powerful alerting. What I'm also excited about is that today we finally launch the new product, Grafana OnCall, which is extending the alert workflow in Grafana. Our team was working on the transition past several months, and later today it is going to be available as a service in Grafana Cloud, right in your stacks. Grafana and other monitorings, they usually have a set of configured alerts, and each is connected to some fixed notification type. For example, if CPU is high, send Slack message to the channel. If it goes back to normal, send another one, or broadcast emails to the whole team. But what if you want to have more interesting scenarios? I've covered some basics already on the keynote, and now let's dig into the details. Most of the monitorings send alerts in JSON format via post requests. Grafana OnCall parses them using a set of pre-configured templates for the most popular monitorings to render the incident, to determine the grouping key, alert status, and other metadata. Also, you can tweak those templates to fit your needs. Grafana OnCall uses regular expressions to route incidents to different escalations. Grafana OnCall Slack integration allows users to work with incidents without even leaving Slack. It makes phone calls and sends SMS messages out of the box. Now let me talk about some basic concepts of Grafana OnCall. First thing you'll need to do is to set up routes and escalations to define who and when needs to be notified for certain types of alerts. For example, in this particular case, the incoming alert payload will match the severity critical regular expression, and it will be routed to the critical escalation chain, which consists of multiple steps. First is to post to Slack channel. In 15 minutes, it will page somebody from the primary schedule. In 15 minutes more, it will page somebody from the secondary schedule, and so on. Okay, we understand who we want to notify. And now we need to answer the question how we want to notify all those people. In order to do that, everybody configures their own personal notification preferences. For example, I prefer to be notified in Slack first, and then if I don't respond in 5 minutes, Grafana OnCall will send me the SMS message, and in 5 minutes more, it will make a phone call to me. All right, now let me tell you a couple of words about the incident workflow. Let's say around 9 a.m., Grafana OnCall receives the alert. CPU is high on the server 1. It will immediately start the incident and send the message into Slack channel. According to the escalation chain I've been showing you on the previous slides. Then, in 15 minutes, it will notify somebody from the primary on call. But what if we get another alert, which will be grouped into the same incident? And if this alert would have the status, okay, Grafana on call will simply resolve the incident and stop the further escalations. In this case, nobody would be bothered, but this incident would still appear in the database and available for the future analysis. Let's check another case when we don't receive the OK alert and we keep getting similar alerts after the incident started. In 15 minutes, Grafana on call will start notify your team, and it will page somebody from the primary on call schedule. Let's say this person would open the incident and click the button acknowledge. In this case, the incident would get the status acknowledged and all the further notifications will be stopped. Then after some time, that person would resolve this incident and it would mean that everything is fixed. Please note that all that time between the start of the incident and the end of the incident, all the incoming alerts would be grouped into this incident, helping the on-call person to better understand what's going on. Now, let me tell you about one of the special escalation steps we have. It's called Notify on-call schedule. What's special about it is that it can define the on-call person in a pretty unique way. It works with different calendar applications where you can create a separate calendar for your rotations, and you can use all the power of those calendars with all the recurrency settings to set up the schedule you actually want to have. You can use Google Calendar for it, you can use Microsoft Outlook Calendar for it, and you can use pretty much any calendar application that supports iCal experts. For those who prefer coding, we also support creating the rotations through Terraform and our APIs. All of that and many, many more will be available in Grafana Cloud today. And now, time for the demo. I've created a Grafana stack in our Grafana Cloud, and please register here, get trialed or open your existing stacks, and later today this logo will appear in the left sidebar. You'll see the name of our product, Grafana on Call, and a bunch of pages. But before opening the product itself, I want to tell you how are we integrated with the rest of Grafana. Let me tell about user management first. Generally, Grafana has the page users where you can configure the usernames, emails, and roles. But what if you want to configure the phone number or connect to the Slack account or set up the personal notifications preferences? That's a job for Grafana on Call. Here we have a page users, which is pretty similar, but with all those on-call specific notifications. For example, I've already filled my profile. I'm clicking the button View My Profile. My profile is getting opened. I already have these 3 fields from the previous table, but what I also have is my phone number, which I can change or add, and my Slack username. I've connected my profile to my Slack account. In order to connect your phone number to Grafana on Call, you need to click Add Phone Number, and you'll get redirected into this page where you get the prompt for verification of your number. Please click the Send Code button and put your unique code over here to actually verify your phone number. After that, I would recommend you to click this button, Make a Test Call, so you'll check the connectivity and also you'll know the phone number which is assigned to you, and it will be permanent. Please add it to your favorites in order to get it through Do Not Disturb mode. Well, I'm going back to the user profile, and here where I can configure my default notifications. If I get paged, I will be notified by Slack mention. Then if no response, it will wait for, let's give it 1 minute. We'll wait for 1 minute, and then I'll get notified by phone. If the alert is critical enough, I can set up the important notification preferences, where I'll be notified by phone call right away. Well, that's how user settings are configured. But that's not all about user management. We also support Grafana teams. I've already created a new team here called SRE and added a couple of people over here. If I go back into Grafana on call, I'll see this select where I can switch between teams. Basically, each team will be a separate place where you can have your own monitorings, own integration, and own incidents, and it will not be interfered with each other. Well, that's all about users. Now let's go to the Slack integration. I've already mentioned that you can connect your Slack account to your personal profile. In order to do that, you also need to install the Slack application into your workspace. Here is a page named Slack, where you'll have a prompt to install it into your Slack workspace. Also, I would suggest you to select the default channel for Slack notifications. Basically, Grafana on call will send all the alerts into this channel unless the different one is not specified. Well, let's now go into the integrations page. In integrations page, we can add the integration with monitoring system and set up escalation chains and routes. I'm clicking this button, new integration for receiving alerts, and I can select one of the tiles over here with different types of, basically this is a different types of monitoring systems, and the only difference between them is the pre-configured templates that help us to parse the content of alert, to know what is a grouping ID, to know what is the status of the alert, and so on. We also have one special integration over here. It's Grafana alerting, your current Grafana cloud stack. These integrations work a little bit different. It will automatically create all the connections with the current Grafana, so you'll get all the alerts into Grafana on call from your current Grafana stack automatically. We don't want to do it right now because it will add a little bit more complexity to our demo, and I'll create just a regular Grafana webhook. Let me do that. Once I've done that, I've been issued with a unique URL which I can post into any Grafana around. It may be even on-premises Grafana or other stack or whatever. As you see, this integration appeared here. Here I can select different integrations when I'll have more. And on this part of the screen, I can change the settings specific to this particular integration. Let me change the name first. I want to call it Grafana number 1. I've changed the name, and now I can set up the escalations for alerts from this Grafana. It prompts me to create the escalation chain for the default route. I'm doing that. I'll call it Grafana escalation chain. Here we are, and it will first post the incident into the Slack channel. Then I want it to wait for a minute. Then I want to notify my on-call schedule. we don't have any on-call schedule yet. Let's create one. In order to do that, we need to go to other page on-call schedules and click the button Add Team Schedule for the on-call rotation. Well, I'm giving the name to this schedule, and I need to open my Google Calendar and create a rotation. Basically, what I need to do is to create a new calendar and add the events over here with the title having my username. Say now is 8 p.m. and I want to be notified. I want to change my shift. Now, for example, I want to be on call from 9:30 a.m. to 9:30 p.m. every weekday. And my colleague Michael, he wants to be on call from 9:30 p.m. to 9:30 a.m. in the weekdays. As you see, I've used the recurrency settings in my calendar, so my recurrency rule here would be weekly on weekdays. And what Grafana on Call would do is that it will go to this calendar and it will check who is on call on the time of the page. In this particular case, it would be me, and let's check if it works. In order to connect this calendar to Grafana on Call, I need to go into the settings and sharing menu and find the secret address in iCal format. I'm copying it and pasting it into the URL input window. That's pretty much it. I'm creating the schedule. And here we are. Here is our primary schedule. As you see, here is me. Today is me from 9:30 to 9:30 p.m. And Michael is from 9:30 p.m. to 9:30 a.m. both days. Means that now I can select this schedule for the escalation step. Now we can shoot some alert and check how it works. Going to the incidents page, you see here is my Grafana #1 integration, and here is my test notification. You see here is the timeline. It registered right now, and it immediately was assigned to default route and sent to the Grafana escalation chain. In the minute, it will notify me, right? But you remember the first notification step was to post into the Slack channel. And here we are. The alert was rendered here. It's from Grafana #1. And here is some payload here is the content of the alert. And that's not all. You see in the thread, it gives me some clue on what's the timeline of this incident, and what's more interesting is what is the plan for this incident. So it prompts me to invite Grafana on Call application into this channel, what I'll do right now. And you see after 1 minute, it notified me using the mention. In 1 minute more, it will make me a call. Let me actually invite Grafana on Call into this channel. After I invited Grafana on Call into this channel, I can work with postmortems. Let's say I've wrote something over here, and now I can add this message into the postmortem. You see Grafana on Call application. It's a small emoji over here, And now all the information will be attached to the postmortem, which is also going to be available from the web interface. Well, I can acknowledge this incident right from Slack, and it will stop the notification. It will stop the notification chain. After I'm done with fixing the alert, I can resolve it. And that's what Grafana OnCall can do in Slack channel. If I reload the incident, I'll find it in this table, and you see here is my incident from Grafana number 1, and it's now in resolved state. Now let's go back into the integrations, and I'll show you how to create a new route. You see, we have a route settings here, and if you type the regular expression, say this one, it will create the new escalation, the new route, and you can create another escalation chain, and you can trigger different rules based on the content of the alert. I guess that's it for my demo. We've covered the most basic cases, and please come to our product. We'll be happy to answer any of your questions in the Q&A session, and then in the Slack channel and in our community.grafana.com. Thanks for joining us. See you soon. Bye.
Hello, and welcome to the Q&A. Looks like Matt Vay's still doing some work. We have a load of questions that have arrived. We're going to work through them in order. It's probably going to feel a little bit like it's jumping around, as we'll cover some of the ones for on-call and alerting according to the popularity of the question, not necessarily in a sort of group. But we'll start. Jacob asked, will Grafana on-call be available on-prem? And there's a second part to that question, which I'm also going to ask, and I'm going to give it to Matt Vay to ask, which is, tell us about the license and the OSS of this. So there's two parts to that question, and it's the most popular question. Matt.
Oh, yeah. Thank you for those questions. So what we announced today is on-call only in Grafana Cloud. It's in beta public preview state, and it's for you to try features, to try how do you like it, to share the feedback. And we don't know our plans yet, but look at the company, Grafana. Almost everything here is open source. It's like popular movement. So that's all I can say. I can share a lot because some of that we didn't define yet, and that's my answer.
Cool. The next most popular question, actually, it's coming to the alerting area, so it's for me, which is it possible to use Grafana alerting with an external alert manager instance? The answer is yes. If you fire up Grafana Cloud and use the Grafana Alert Manager drop down, you can set the notification channel to be an external alert manager, and that's true in the Grafana OSS. It's the same thing. So if you use Grafana OSS, you can point to a different alert manager. So you could easily just point it at your existing Prometheus alert manager elsewhere and have Grafana do the evaluations, or vice versa. You can chain them together in different interesting ways. The next question from an anonymous, so I can't credit you with it, but is it possible to configure alerts based on anomaly detection based on the metrics? And what would be the high-level steps to do this? The person who's sort of owns this is not actually here, but the answer is yes. I'll answer on that behalf. We have some documentation on this, which you can actually see on the grafana.com website if you do the machine learning. We output Prometheus metrics series that you can alert on, and those Prometheus metrics are the product of the anomaly detection system, so you can alert on that. The next question, I think I'm going to give this to Ildar, which is there any plan or already an integration to integrate Grafana on Call with MS Teams, Microsoft Teams?
That's a good question. I showed my demo on using Slack integration, and currently we support only Slack. And we'll be happy to hear our community, and we'll definitely consider supporting MS Teams as soon as possible.
Great. How should people let you know?
I guess
in Slack, we have a Slack Grafana community where everyone could reach out to us and share the ideas like anything you like or you don't like about Grafana on Call. We'll be there. We'll be listen and maybe invite some of you for interviews to learn better what to expect.
That's for sure, and also our community forum.
A very similar question is next from the user F30. And this is which notification methods are available for Grafana on Call? And the most critical one, this has been asked internally as well, is there going to be an app for push notification on the go and being able to axe and stuff? So Matvey.
Yeah, as you probably noticed, that Grafana on Call is very corporate messenger focused thing. So if you already have Slack, we designed Grafana on Call in a way you don't need additional app. And we covered all popular use cases. You are able to acknowledge, resolve incidents. You are able to even record resolution notes and build war room, invite your colleagues, do a lot of work right inside the Slack app. So we tried to avoid the need of building mobile app. But as Ildar said, if you say out loud that we really need it, we will build. One of the popular questions why people are asking for mobile app is to add mobile phone. So Grafana on Call is able to make phone calls, and it's very popular demand to add the phone number to the DND, and that's why somebody installing mobile apps from other vendors. But actually, Grafana on Call is using the same number all the time. So feel free to go there, click the button, make test phone call, receive a phone call, save the number, add it to DND. So this use case will be covered.
The next question, also from user F30, which is the next most popular question, is in a very similar area, actually, but it deals with a point of confusion. How do integrations like PagerDuty work? Is it the case that PagerDuty alerts can be delivered via Grafana on Call, or Grafana on Call alerts delivered via PagerDuty? So this is really what place does Grafana on Call take in this alerting setup?
I'll take this question.
Sure.
We support both outgoing webhooks and inbound webhooks, and our system can be anywhere. I guess this question was out of my demo, and I've been showing the pop-up with the different integration types. So that was inbound integrations. And yes, we had a pre-configured set of templates for PagerDuty as well to render them right.
Great.
So it's up to users to decide where do they want to put the system. So we give you instruments if you want to use, for example, scheduling from Grafana on Call or escalation mechanism or even notifications from Grafana on call and store incidents in somewhere else, feel free to do it. So our purpose was to make it as integratable as possible. I don't know if this word exists, but
Does now.
Yeah.
Great. The next most popular one is from JJO. Oh, it just changed around, but from JJO. Similar to Grafana's provisioning, which you can do from sort of using GitOps. So you would actually do it via code. How does this work for Grafana on call? Can we deploy things, define schedules, users, escalations, and everything using code? And Ildar.
Yes, we are going to support Terraform to automatically configure all that configurations, and we'll be announcing it pretty soon after the launch.
Okay, cool. I'll actually tell people we already use Terraform internally, so we're already doing it. I think it's just a case that we'll polish up some of the docs, but we already do it, so it's already there. I'm going to stick to the same area, which is it possible to import on-call users and their data from Active Directory, LDAP, and other data sources? I can imagine the answers down the same line, but Matvey.
So Grafana on call is 100% time, part of Grafana Cloud. So it's working with the same users, the same access, the same permissions. Everything is super integrated. So a shame on me. I don't know if Grafana Cloud support this, but I guess yes. So if you will be able to connect it, yes. Okay, I didn't try just. So yeah, answer yes. Just connect it with Grafana Cloud, and all users will be in Grafana on call.
Cool. There is a theme in the last couple of questions that have emerged, and it goes back to the first question, actually. So I'm just going to acknowledge that to the people who are asking. We do see it, and it is the question of, is there a roadmap? Is there a path to Grafana on-call being available on-prem? Now, we've answered earlier that we are in cloud at the moment, but we hear you, and Matvey and Ildar can work on actually telling that story as we go forward. Matvey.
Yeah, I want to add one important topic that the thing that we started with cloud version, it actually makes a lot of sense because we identified the huge desire to keep alerting and notification system in outside of your infrastructure. So that's why we started with cloud version. And I think that Grafana on call is the most cloud native product available from Grafana cloud products. So it's really nice to have it outside of your infrastructure. And I see and I think I understand why you ask about on-premises and about launching it locally. But think about it twice, that probably if something goes wrong with the infrastructure, you would like the system to be up and running somewhere else and notify you.
Cool. We've gone through most of the questions, but there are a bunch of questions we did not get to. We will hang out in the Grafana community Slack. But thank you all for attending. Thank you for watching this. I hope you were excited by what you saw at the keynote just prior to our session as well. And yes, thank you.
Thank you all.
Thank you. Bye-bye.
Hello, I'm Karel Meert, SRE at TomTom, the location technology company. Today, I'm going to share about our journey in the adoption of Grafana Cloud. You see here a lot of fancy words, but actually what I'm going to try to say is I'm going to share our journey on why we started with Grafana Cloud. There was a one specific problem we tried to solve, and our journey, what we learned, and the other problems we solved along the way. How will I do this? I will start with providing first some context on TomTom as a company and our organization, our structure, because that's important to understand the context. Then I will give our problem statement and what we have done to solve it. Okay, TomTom. So TomTom, location technology company. We are working mainly in the automotive market, but the enterprise, so Internet of Things companies, can be governments, can be fleet management experts, and so on. And of course, consumers. So the small little devices you probably know, which are used in the cars. Here you have an idea on some of our major customers. But maybe more interesting for you guys is that we also have a big developer community. We have quite a lot of data which we make available over APIs and SDK data, like traffic information that can be routing from one point to another point, or searching a certain address, all different kinds of information regarding to location technology. And if you want to try it out, we have you can actually use 2,500 transactions daily, and we have quite some good support. And we guarantee privacy of our customers' data, which is not always that common in our market. Good, the SRE team. So I told you already that we have quite a lot of APIs available. Often those endpoints are maintained, developed, maintained, put in production, and so on by a single developer team. So the SRE team itself doesn't own any service. It's all the developer teams that own their services. The SRE team is the knowledge experts, everything regarding observability, reliability setup. We're also on call. So if there is a major incident, we act as incident commanders. And after such an incident, we actually lead the debriefing, so the post-mortem root cause analysis. Good. What problem did we have? I think 2 years ago, we had some big issues with a certain automotive customers. The SLA was breached, and we started to investigate, like, okay, what's all the things we can help to reduce our MTTR? And one of the things we really faced is we had a lack of visibility of what the actual status was of this service. Different engineering teams had a view on their own services, but they were not shareable over the different engineering teams. Some teams used like Prometheus, other teams used like other sources, other monitoring tools, and it was really, and often they were conflicting. So this was actually a big issue. So the first thing we introduced were the business dashboards. And actually it didn't took us too much effort and time to bring all these different sources into a single board. For example, what you see here is on the left top, you see some SLA information coming from, in our case, from ServiceNow. On the right top, you see the results of a black box monitoring tool. In that time, we used another tool. It's with iframes, which is suboptimal, but we're also improving on that. And then you see a couple of rows representing the actual services itself. So here we got on a embedded, fast way, a single view of what the status is of the complete service. So this was really for us the first point, the first problem we solved with Grafana Cloud. So along the way, so we solved a bit that business dashboards, but along the way we also said, there is another thing that we actually would like to do, and where Grafana Cloud could be really a good solution. And that were our technical operation reviews. So we were introducing this practice of doing weekly a technical operation review. This technical operation review is an exercise we do with a couple of teams together, and each team represents the metrics of the past week. The on-call engineer represents these metrics and goes through, okay, this was the behavior of our service, and they learn by doing this what the normal behavior is of their service. And if there are any anomalies, they say, okay, hey, here in our P95 or P99, or we see a certain amount of error rate, which is abnormal. They go deeper into that. They discuss it. Maybe they already know the cause, and other engineers they help each other. So it's also a kind of knowledge sharing. So very interesting exercise. It's not rolled out to our complete community, but it's really growing. And we built those dashboards also on Grafana Cloud, so it's shareable overall company. A third thing that we learned and it was already around I think less than a year ago, said, okay, we now have this synthetic monitoring of Grafana Cloud, the successor of WorldPing. This is actually quite interesting, because at TomTom we have 9 different tools we use. Same issue here, 9 different tools. Not everyone has access to those tools, so you reduce the visibility there. One team, if you move from one team to another, the thing what you have, all the negative points you have with having so many tools in place. So we said, if we now start investigating on synthetic monitoring, what could this be as a standard for TomTom? So we started this exercise, and actually it ticked most of our boxes. So the user interface is pretty good. And it embeds very well in those Grafana boards. If you recall those business dashboards that I showed, it was only showing an iframe of a specific tool that we used. Now this synthetic monitoring, really, you can say, okay, from 7 days, 8 days, it moves along. With those iframes, you don't have that functionality. It's configurable as code in Terraform, which was also a very good thing for us. And then, the checks itself are easy to set up, but the alerting itself mechanism, it's using a bit the same principle, same technology as Prometheus. And not every engineering group is using Prometheus. So for the groups that are using Prometheus, this alerting setup was also very straightforward. But we saw for some teams that we are not using Prometheus, this was a bit of a learning curve. And also, we have this one single Grafana Cloud environment, and then a lot of people have edit rights on it. So if you want to hide some secrets in your checks, these were accessible and visible for everyone with editor rights on Grafana Cloud. So, but okay, we didn't found that a major thing, but it's something that we gave as feedback also to Grafana. This would be beneficial if that would be tackled. And not all our use cases are covered. So we have this multi-step complex checks, and we were not able to put them all in Grafana Cloud in synthetic monitoring. So the current status is default for us is synthetic monitoring of Grafana Cloud, and for those very specific complex checks, we use a second tool. Maybe also interesting is that the cost model, we found that very appealing. You don't actually pay for the tool, you don't pay for the checks, you actually pay for the data you generate with those checks. So the amount of metrics, the logs that you generate, that kind of stuff. And that was really, if you compare it with other tools, this was really a big delta. Okay, then the reason why we chose for Grafana Cloud. There are a couple of reasons. Within TomTom, you saw the use of Prometheus, Alert Managers, Grafana, you saw it popping up everywhere in our company. Not everyone was using it, but it was really getting quite some traction. So this was already one reason. And the second reason is the ones that are not using Prometheus and not using using other tools, it was easy to embed that into Grafana Cloud. And another problem we tried to solve was this high availability and this retention times of metrics with a remote write. And so you have your own Prometheus, you remote write into Cortex, into Grafana Cloud. You actually solve those problems also with Grafana Cloud. And then the question we had, so Grafana was a bit the de facto standard, the logical choice, but then we had to make the choice, are we going for a self-managed solution, or are we going for the SaaS solution of Grafana Cloud? And there, there were a couple of reasons. As you see, we are only a team of 5. We're extending, but we didn't have too many resources left. Having it as a SaaS solution really helps. So that was one reason. The cost was not that high. We found it convenient. There was a good support. But then for us, the final reason to really go for a SaaS solution was like, imagine that there is a situation where the cost of Grafana, the current cost is okay-ish, but for one reason or another, the cost would really go rocket high. The fallback from going from Grafana Cloud back to the open source solution is not that big of a step. So the fallback, if the cost would really be that high, the technology alternative was there. So these reasons made us really go for Grafana Cloud. Then, what are our plans in the future on Grafana Cloud? So we put our metrics there. We use our logs as a data source now in Grafana Cloud, but we're actually not using Loki as our default log handling tool. This is something we are going to review coming year. We are doing quite a lot on distributed tracing using OpenTelemetry. Currently, for our proof of concept, putting a lot on in Jaeger. But we think that bringing it into Tempo, this data, would also be beneficial. So that's something we explore. Synthetic monitoring, we already explored, and we are going to extend that. And we saw some appealing things on incident response. So also that catched our eye, and we definitely going to go further and explore that. What are the main takeaways we get from our Grafana Cloud experience? I think we can say it was easy and fast to implement. So we did that business dashboard. I think from problem statement to actually having our first business dashboard up and running was 2 weeks times. And actually in the beginning, we only aimed for having the response times, but actually we got most golden signals there, error rates and so on. So this was really for us a good experience. The cost is relatively okay, certainly because we didn't have to maintain anything and so on. So that was a good experience. The support itself from Grafana Cloud is good, and we saw all this along the way. We saw this like the synthetic monitoring and all these new features appearing on regular time. This was really for us a pleasant surprise and a good experience. About TomTom, I think like any big technology company, we are searching and hiring. So feel free and check out our site on that. And if you're interested in our data and want to play a bit with it, check our developer community. I hope this was interesting for you and it can help with your journey in using Grafana Cloud. Have a nice rest of the conference. See ya. Bye. Hello, so I'm here for a Q&A session. And the first question I see here is, do you have tips on using Grafana Cloud across a big team so you don't get billing surprises? How do you control metrics, explosions, or dashboard sprawl? I must say, in the beginning, we have a couple of hundred engineers, and we were in the beginning very conservative. We shared the possibilities, but each time if people want to do a remote write, put a lot of metrics on the system, we said, go for the let's say the golden signals, be very selective. But what we saw is that actually we are now more liberal on it. And what we take here, of course, if you have a large Kubernetes cluster, you want to send everything, you immediately get a lot of metrics into the system. And what we do here is, if you have only a limited amount, and what we call a limited amount is between 10K or 100K, then we don't really bother with that. If a team is really going to send a lot more metrics, then we come into we could go in a meeting with them and we try to optimize their remote write and be more selective in what they send. And to avoid surprises, you have dashboards. We check them on regular basis and we put some alerts into the dashboards we have with what we see. I hope that answered that question. Then another one. What are the rate limits with TomTom API like? It depends on which endpoint you use. So there is no single rate limit on a certain API. Then I see it. Last question. Can you provide this service on company premises or is it available on cloud only? I think you're referring here to the TomTom services. Yeah, it's an API, so we of course we can deliver map data, but the services that we are talking about is all cloud. Yeah, I think that's it on the questions. So good luck and have fun. See ya.
Hi everyone, I'm Devin. I'm one of the product managers here at Grafana Labs. I'm kicking off our session around getting faster queries and analyzing more with Grafana metrics. So by sending your metrics to Grafana Enterprise or Grafana Cloud, you're going to benefit from all the investment we've made in this area. We've built and launched a number of new features this year, and we're going to announce and preview some more today. Before I get into the agenda, I did want to mention a feature we released last month, and that is our Grafana machine learning feature. This is a new metrics forecasting capability, and it's going to allow you to run modern data science techniques on Grafana Cloud metrics. So with this, you can visualize predictions and solve real-world problems with features like adaptive alerting, anomaly detection, and even capacity planning. So please check out our blog or sign up for Grafana Cloud, and you can learn more about that feature. So what's on the agenda for today? First, I'm going to talk about how we've improved the query performance for Grafana Cloud and Grafana Enterprise metrics. Dieter then will go into a preview of a new high-resolution histogram that we're building. And Mary's going to end with a new feature that will help you prevent and manage cardinality explosions with Grafana. We'll then have a live Q&A and would love to hear your questions. So let's get started. First, what do you think when you see this icon and this message? Let's say it sticks around for 15, 30, maybe a minute. Yeah, it doesn't feel great. But it would be even worse if you were on call It's the middle of the night, you get paged, and you pull up your observability tool, and you start to see some of these icons behind some of the queries you're trying to run, or even the dashboards. And then the Slack messages start to pile up, and you're starting to realize that this is a major outage. And maybe even worse, you're pretty confident you have a good idea behind one of the contributing factors, but you can't validate that with data because your tool is just not returning a result. You're maybe going to feel like doing this. So how do we go from a state of frustrated to a state of flow? And maybe even more interestingly, why does that even matter? Well, it turns out speed really matters when you're investigating unknown unknowns. Modern distributed systems fail in unpredictable ways. And having the ability to quickly interrogate the system with a hypothesis and then validate that or invalidate it and run another one is really, really important, especially in that troubleshooting context. Working memory and holding the previous queries you ran really helps. And if the query is slow or doesn't return a result, it's kind of hard to remember those previous queries and really get into that state of flow and that state where you're able to validate or run through multiple hypotheses. So Prometheus and PromQL actually is pretty fast. And we do have some interesting talks from previous years on how we've done that. But our customers are sending us even more metrics, approaching 1 billion series. So scaling for that kind of ingest is difficult, but scaling for query performance is even harder. Folks like Robinhood's are sending us up to 700 million time series. And the technique that we've been using so far for query acceleration, per day query splitting, is not enough anymore. That technique would take a query that goes over a day, split it into single day queries, and run those concurrently. But it doesn't accelerate queries below a day, and we've found that high cardinality queries can actually be painfully slow. When you start to approach the 30 to 50 or more thousand series, 50,000 series, it can be pretty slow. Query sharding is the technique that we've implemented to really respond to this need. Let me walk you through an example. So SumRate is one of the most popular PromQL queries. And what we would do here with query sharding is take and split that into 16 separate subqueries. Each of those queries can be run in parallel, either on a different CPU or even a different machine. Then those results of those subqueries are aggregated in the query front end. And let me show you what that results in terms of performance improvements. Here you can see what we would consider a medium cardinality query, touching about 80,000. Previously, that would take about 38 seconds without query sharding. And we've seen that get down to about 4 seconds. Even better in a way is when you're dealing with on the order of hundreds of thousands or maybe even over 1 million series that you're trying to traverse. We often would see no result returned. With query sharding, we're starting to see results even at that sort of scale. One of the other things we learned was this idea of dynamic sharding. That is deciding on the amount of shards based on various factors like cardinality. And this is going to really help us respond to the needs of our customers around performance. So thanks for listening to the quick explanation of query sharding. We really hope it'll help you respond to those types of issues and improve your satisfaction with Grafana Cloud metrics and Grafana Enterprise metrics. I'd be really remiss if I didn't give a massive shout out to the engineers who built this. I'm just really lucky enough to demo and talk about the feature. But Marco and Cyril actually came up with this idea during a hackathon. They proposed it, implemented it, and it's going to go to production this month. So to start to take advantage of this, if you're using Grafana Enterprise metrics, you're going to need to update to the latest version this month when it comes out. And for Grafana Cloud metrics, again, it'll be available this month and no action is required on your end. So thank you for listening to this talk. I hope you enjoy the rest of ObsCON, and thanks again.
Hello, my name is Dieter Platink, and today we're going to talk about new histograms in Prometheus. If you're wondering who I am, I have been with Grafana since 2015, and I have this very old picture of myself, Raj, and Turko to prove it. In all these years since then, I have worked on Grafana alerting, I've worked on WorldPing, which is now synthetic monitoring. I've spent a lot of my time working on our graphite products. And recently, I've also been getting more involved with Prometheus. So let's talk about histograms the way they are today. And if this was a real conference, I would like to do like a virtual show of hands. But I have a little secret to tell you, which is this is actually a recording, and I'm actually doing this 2 weeks ago. So even if I got your feedback right now, I still wouldn't be able to incorporate that into my presentation, but that's okay. I'll just collect your feedback at the end of this session. So the way a histogram currently works in Prometheus is that you have a separate series for every single bucket. And a bucket is simply a range of observation values. So in this case, we're collecting latency observations. And then based on their value, we categorize them in certain buckets. And each bucket has its boundaries, which are listed here on the LE label. But let's visualize that a little bit, because that sounds very abstract. This is a heat map, which visualizes a histogram over time. The more bright rectangles are regions with more requests. So what we can see here is that a lot of our requests return between 10 and 25 milliseconds. And then sometimes they get a little bit slower, up to about a quarter or half of a second. And then also at the bottom, you have this separate class of requests, which all return in under 5 milliseconds. And this is one of the benefits of heat maps, is that you can see different categories of requests, different classes, whereas on an average or a percentile, all the data gets averaged into one measurement. But here we can see we have two separate kinds of requests. So this is just one way to use the data. Another way to use the data is to generate aggregate statistics from them. In this case, we're generating the median as well as the P90, or the 90th percentile. And this is what histograms are really good for. Because if you had, let's say, multiple copies of the same service, and they would all generate their own aggregate statistics, like their own P90, if you then wanted to get the aggregate P90 across all of them, you wouldn't be able to reliably calculate them. We're not going to go into the math too deeply here, but basically the only way to reliably calculate aggregate statistics across many services or copies of a service is for each of them to expose a histogram and then merge those histograms and work on the merged histogram. So this works pretty nice, actually. But there's a couple of problems. The first one is a problem of precision. In this case, we have not configured our buckets to properly correspond to our observations. If all your observations, and this is an extreme example, of course, but if all your observations fall within the same bucket, then you can't really know much about their value. The only thing we know is that they're somewhere between 50 and 100 milliseconds, but we don't know where within that range they are, and we can't get any really accurate information out of that. So that's why I would recommend to choose your buckets such that they're all narrow enough, and so that your observations, they all get spread out across many buckets. That way you can get much higher precision. This is a more extreme example of the same problem, because the highest bucket, it always goes up to infinity. So in this case, we have no idea if our requests are just over 500 milliseconds, or there might be minutes or hours even, who knows. And your precision is just very bad. So choose your buckets carefully. If you have chosen your buckets carefully and you're kind of happy with how all your observations fall within your buckets, you spend a lot of time optimizing it and tweaking it, and you're happy with it. But then somebody decides, okay, we have a new objective, a new SLO. 99% of our queries have to respond within 150 milliseconds. To answer a question like this, you need a bucket boundary at 150 milliseconds. But in this case, we don't, so we can't answer this question. Another reason to change your buckets. Then let's say you have an optimized bucket layout for one service, and then you have another one for a different service, and you need to aggregate across the services. Or you had an a bucket layout at one point for your service, and then you changed it, and now you have a different layout. For most queries, you will need to aggregate them. They need to be compatible with each other. And in this case, what we see is that while many of the buckets, they can be merged into one another because the boundaries, they align. Here's actually an example of one boundary of 150 milliseconds that doesn't correspond to any of the boundaries on the left side. So these histograms cannot be merged, and that's a big problem. So using histograms right now is a bit of an exercise in like always adjusting your buckets to be just right and spend a lot of time maintaining them over time to satisfy the information needs, you know, like the SLOs and the percentile requests and stuff like that that you have, and control the precision like we saw. But as we saw, buckets must be aggregatable with other series because you may need to aggregate across different services or different copies of the same service, or like I said, even for within the same service, if you just change the buckets, most queries will actually need to do an aggregation on it. And if the layouts are not compatible, you can't do those aggregations. Then every new bucket results in a new active series, which gets expensive. And it may hold you back from adding more labels. So if you wanted to segment your histograms by, for example, HTTP status code or HTTP route, you just generate so many new series that or maybe your data will change. Maybe your service will suddenly respond a lot faster than it used to. That's another reason why now you need to change your buckets so that they're compatible again with the kind of observations you have. And then finally, deploying new bucket layouts is just no fun because you literally have to roll out your services again. You have to like reconfigure them, recompile them, redeploy. It's a whole process. It's very annoying. So all of this together is just impractical. So let's have a look at how we solve this problem in the new version of histograms. There's a team working on this, myself, Bjorn Rabenstein, and Ganesh Furnakar. Ganesh and Bjorn are Prometheus maintainers. So at Grafana Labs, they work full-time on Prometheus. We're now in the prototype phase. So we have the design. The prototype, we're pretty happy with it, but we want to do some more testing, more tweaks, maybe change things a little bit. But obviously, we want to get to the point where it becomes production ready and then merge it into Prometheus and make it available on Grafana Cloud and on our enterprise metrics product. So this is how the new histogram looks like on a heat map. It's kind of the same as before, except it's much higher resolution. You can see a lot more details. But this is actually not the most exciting part. This is just on the surface. To actually explain what's happening behind the scenes, I have to explain what our histograms actually are. And for that, I came up with a term for our histograms. I just need to take a moment. You'll see why. I call the new histograms high precision, just about zero config, allocating sparse, but in a way also quite dense, actually, gorilla style with lots of bit twiddling, single series histograms. Phew, okay, so basically we are reimagining histograms from the ground up. So I also have to explain it from the ground up. Histograms, we know what those are by now. Single series means that we no longer have separate series for every separate bucket. Instead, all of that bucket data for the entire histogram is encoded within one series. And we do that with an encoding style that's based on Gorilla. Gorilla is the famous white paper that came out of Facebook. Lots of time series databases apply those techniques, including, you know, Prometheus regular time series. But we basically adapted it to work well for all the buckets of our histograms. And we spend a lot of time to put as much information as we can in as few bits as possible. And that's why I call them quite dense. But they're also sparse because you only encode data for the buckets that are actually being used in your observations. So for all the buckets that you end up not using for whatever reason, those are not encoded, and so there's no cost for them. So that's what automatic bucket allocating means. We just only encode what is actually being used, and it dynamically adapts to whatever your observations are doing at any point in time. This also means that there's almost no configuration. You don't have to explicitly define your buckets anymore. The only thing you really have to define is the factor that controls the width of the individual buckets, so the precision of the buckets. Because we will just scale up the buckets in some kind of known pattern that automatically grows over time, that grows, as the values get larger, the absolute values, the ranges get larger, so that the relative precision stays the same. But the only thing you just have to define is the factor of the precision. And high precision is possible now because everything is so much more compact. It's all within one series. And this basically enables you to use high precision buckets, which results in that visualization like we saw before. Some characteristics that result from this is that you can get high precision, but it's also consistent. So even if your observations that, maybe they start getting slower and slower and higher values, now it will automatically just create those buckets as you need them, and the precision will stay the same. Or if your observations just go down and get closer and closer to zero, we generate smaller and smaller buckets automatically. And because the new histograms are more lightweight, it also enables you to partition. So now we can partition by, by status code or by HTTP path or whatever other label you want. And you don't really have that same cost anymore like you had before. And then finally, now we can always aggregate different histograms together, even if they use different buckets, even if they use different precision settings. The buckets are always chosen so that they're always a multiple of each other. So they will fit in each other. And you can now aggregate across different services or different copies of the same service, even if they use different buckets. So this basically solves all of those problems that we saw. The only remaining problem is that it's not available yet. Yeah, it's a prototype right now. We hope to get this merged in Prometheus in, I'll just say 2022. And of course, as soon as it's merged in Prometheus, or maybe even before, I'm not sure yet, we're going to make this available to our customers on Gem and Grafana Cloud as soon as we can. Maybe in some sort of preview mode, we'll see. And then to wrap it up, like I said, I'm in the past right now, so I can't take your feedback, but there should be a real-time version of me, hopefully doing his job and posting a poll right now to the ObservabilityCon channel on the Grafana Labs Slack. So please respond to the poll and share your feedback so I can learn from it. And of course, or hopefully I'll be live in about 10 minutes. We'll do Q&A after the next section, which is Marie's section. I'll see you there for Q&A. Thank you very much and enjoy the rest of the conference.
Hi, my name is Mary and I'm a product designer here at Grafana. I'm speaking to you today from the western part of New York State in the United States. And today I'm going to talk to you about how to manage cardinality explosions with Grafana. So before I start the talk, I'm just going to quickly run through the agenda. First, I'll discuss what are cardinality explosions. Then we'll talk a bit about why those matter to our customers. And finally, I'll do a demo. So, as I already told you, I'm a designer here at Grafana. And as part of our product design process, we spend a lot of time talking with our customers. Something we've heard from folks in a wide range of organizations is that they want to be able to better manage sudden spikes in cardinality. So what do we mean by spikes in cardinality? Let's imagine that we're on a team, and this team that we're on is tracking the number of time series that we send to our observability system, just so we can keep an eye on how much monitoring data we're actually producing. And let's say that as part of that tracking, we see a graph that looks like this. So see how the line goes down a little bit in the middle here? Perhaps we change some relabeling rules to drop some irrelevant labels. But then what happens is the line spikes up. And what happened here is that maybe someone introduced a label that can have so many values that the number of series is increasing rapidly. This means that we're generating a lot more monitoring data than we were before, and perhaps accidentally too much. So when can this happen? When you instrument your code and add a new metric, sometimes you attach more context than you need. So for example, if you use the label user ID will become the label for that metric. And since our efficient storage creates one series per label combination, you won't end up with a lot of series for a single metric if you have a lot of users. So what is too many series to send? Hundreds? No. Thousands? Maybe. More than that? Definitely. It's all about being sensible about the overall number of series you send. And the cardinality management tools that we built will allow you to better make those decisions. Before I move to the next portion of the talk, I do want to mention that if unbounded labels are needed as part of your observability strategy, you can always choose to simply log them, and you can use Loki for that. So moving back, over the past year, we've improved our time series storage system so that under normal use, high cardinality is no longer an issue. But as the operator of an observability platform, you should have the tools you need to help you protect that infrastructure. When you have a cardinality explosion, it can cause problems. It's a surprise, it's noise, and it can increase your costs or cause performance degradation. What we've heard from our customers is that they want to see actionable data about cardinality. They want to be able to see this data and quickly figure out where these sudden increases are coming from. So what I'm going to show you today is a set of dashboards that we built to help you better manage your cardinality. Now, one key characteristic of these dashboards is that they give you the ability to drill down from a general to a more specific view of your data. So you start by checking the overview, and then you can navigate to two other dashboards that contain more details about your labels or your metrics. So just to set the stage a little bit, let's say that you're a person at a large company who is in charge of that company's observability system, and you have other members of your team who are sending metrics. And let's think back to the scenario I mentioned a bit earlier in the discussion. So someone on your team has decided to create a label of user ID, and you have a lot of users. So this is going to cause you to start seeing that large spike in the number of time series that are being sent to your system. But when you open up this overview dashboard, what you see is the information that you need to put yourself in context and to also help you start to solve your problems. So if you look here, you'll see the total metric and total series. Down here, you'll see the total label names and the total unique label value pairs. So what you really need to assess your cardinality, you'll see right here, which is the top cardinality per metric. And here you can see the metric, the number of series, and the percentage of total series. And we built out this small visualization so you can immediately recognize if there are any problem metrics or any metrics where you should do a little bit more digging to find out if this is where the issue is. As you go down, you'll see over here the top labels by value count. And here what you have is your label, the number of unique value, and again, the percentage of the total unique values. Similar to the top table with the top cardinality per metric, we have a visualization here to help you quickly identify if there are any labels that you need to check out, if there are any problems that you can easily identify. So if we look here, this metric, container memory failures total, looks like it's what may be causing the issue. So I think I'm going to dig down a little bit deeper to find out more information. So if I click in here, what I'll see is what we're calling a drill down dashboard for a metric. So this is where we can see the metric and some key information associated with that metric, like the number of series and the percentage of total series. And then you can see the label value per metric. So you can see the labels that live underneath that metric and then the total number of values for that label. We have a visualization here, a tree map, to help you kind of like visually quickly identify any problems. And we also have a table here with the number of values sorted from largest to smallest. So we see here that our label user has the most number of values. So we may want to dig in even a little bit deeper. And this is our final dashboard. This is where you can check your labels and you can see the top distribution of series per label value. So here, if I check it system, this may be where I want to look to start seeing if I've had any major cardinality increases. So that is these are our new cardinality capabilities that will be available in Grafana. As always, we would love to hear your feedback. We have a lot of ideas for where we would like to see these new capabilities go in the future, and it's always great to hear your input. So when can you get it? When can you have access to it? Cardinality management is coming to GEM with the 1.6 release, and it will be available in Cloud later this month for Cloud Advanced customers. And we're also making the API available in an upcoming release of Grafana. So thanks for listening to my talk on taming cardinality, and now we're going to move on to a QA. If you're interested in trying out any of the features that you've heard about today, please note that you can start a Grafana Cloud trial for 14 days to get started. Thank you so much. Hi.
Hi.
Hello.
Hey, how you doing, everyone? Thanks. So we have a few questions here from the team, for the team, from you all. So let's start out. Let's just go in order, and we'll start out with some questions on query sharding. So Devin, question for you. Is this going to be a cloud-only product? Is it going to be an open source solution? Just wondering if you can talk to that a little bit.
So this month, we're going to release the query sharding improvements to the Grafana Enterprise Metrics product and the cloud product. We don't have a date yet for the open sourcing of query sharding, but as you've seen in the sessions, we believe in the open source approach. And so just watch this space for the date for that.
Got it. Cool. And Dieter, I have some questions for you on the histograms. Number one, is there any work in progress? And this is actually a question from Slack. So is there any work in progress code on GitHub that's available for people to take a look at?
Yes, everything is a work in progress, and it is on GitHub, and everyone can find it in the sparse histogram branch. So if you go to GitHub and you look at the Prometheus repository and you look at the client Golang repository, and there you just look for the branch sparse histogram, that's literally where all of the work in progress is going. That's where all the development is happening. And it's not yet merged in the mainline branch because obviously it is a work in progress.
Okay. And then will the new histograms, will they ultimately be open source?
Yeah, that's the plan. We're developing this in the open. We want to get this merged in Prometheus itself, which of course is open source. And then once it's in Prometheus, we can also integrate it in our products, on Grafana Cloud, on Enterprise Metrics. Maybe we'll even offer a preview in our products first, because before it gets merged in Prometheus might take us a little while. But I think once it gets merged in Prometheus, that's when the whole ecosystem, I think, will adopt it.
Great. Cool. I see some new questions coming in. So I see a new one here. Can you elaborate more on the cardinality API? Will we be able to use that to create a dashboard similar to what is shown? And Devin, in the PM role, I'm not sure if you want to really talk about that at all. My assumption is
I think we have
the data, but
yeah, I
go
think
ahead.
just to set expectations is that there's a plan to have it available in OSS Grafana. The API specifically, I'm looking at the wrong question, but I don't know if we have a specific date for that yet. So, you know, we kind of work in quarters, our fiscal quarters. So that's up until the end of January next year, so end of January 2022. Before that date, we don't actually have a plan, I believe, to have it in open source Grafana. So it'd be sometime after that.
Got it.
Sort of TBD then on the details. I think there was a question around recreating the dashboard, which would probably be likely, but TBD. Sorry, I don't have more specifics than that.
No, thanks for taking the question on cardinality from me.
I think there was also, is this for all Prometheus data sources? So that would be yes. It's for Prometheus data sources and any existing docs available. The docs will be available. I don't believe they're out yet.
Not yet.
The feature isn't GA yet. I think it's coming. It's going to be coming this month. I think, like Mary mentioned, but we don't have existing docs today. Once it goes live, they'll be available. So next few weeks.
Great. Cool. So it looks like that's all on our end. Thanks so much, everyone.
Thanks, Mary.
Thanks.
Hello everyone, I'm Walter Hitzel and I'm here to present the lecture about how product teams can manage their performance through the use of Grafana, Prometheus, and Oracle. And to start with the right foot, let me tell you right away about what this lecture is about. I'm going to share with you how my team have developed something we call it product team observability to help us during our digital transformation journey. I will show our dashboard, the metrics we are using, and explain how we did it. The second thing that I would like to share with you is the benefits of this approach, and with that also prove that product managers are really bad on estimating their own efforts. And without further ado, let's move on. My team recently have started a digital transformation journey. So this means that we are moving from a project-focused approach into a product-focused approach. So with that, the main point that we have noticed that is different is that we have a huge ownership over our products. And to be able to have all this ownership, we are learning to use a new set of tools and doing a lot of stuff that we didn't do it before. And back in the project days, if we had a up-to-date schedule and we have a really good backlog, we are all set. The project manager could predict how our delivery will go and most of the things about the project. And with that also check if the team are really good performing or not. But these have changed, right? Now in the product model, we have the metrics backlog, we have user metrics, we have team maturity metrics, application metrics, survey feedbacks, DevOps metrics, and the schedule and the backlog. And all that needs to be used to understand how we are performing, if the product is going to the right place, and reaching the goals that were set at the beginning. And all that is really, it's really cumbersome to to get all this information. So unless your product manager can grow several arms to deal with all that, we need to find a smarter way to collect all this information. And because of that, we have looked into the observability field and built something that we call the product team observability. Basically, we are using the concept behind the observability and are trying to use that to monitor our team and get insights to improve our performance. For that, we are still using the 3 pillars of observability: metrics, tracing, and event logs, but probably we are selecting some different topics to evaluate inside those. In metrics, we are caring about user KPIs, business KPIs, stakeholder KPIs, backlog KPIs, and deployment KPIs. On tracing, we are talking about maturity levels, progression, and compliance reports. In event logs, we care about the pipeline logs, the application logs, the database logs, and vulnerability logs. All that is being consumed and used to produce our product team observability. And how we did that? The architecture that we have built is this. Basically, we have created one ETL process that extracts information from different places using APIs most of the time. So we can get information from Pivotal Tracker, that is our backlog, GitLab, that is our source repo. We have the Poma tool, the DevOps tools. We collect all the application logs and put that into Splunk, and we consume from Splunk. We have the satisfaction surveys. All this is processed into a multi-dimensional model, really similar to the old data warehouses. And this information is stored in our Oracle database, which later is queried in 2 ways. Through an API, we deliver the time series into Grafana Enterprise Metrics, or we deliver straight into Grafana some queries where time series are not applicable. And of course, at our front end, we have Grafana showing the dashboard. And let me share with you how this dashboard is structured. So this is our dashboard. We have the main dashboard divided in 2 main sections. The first half of the dashboard, we have mostly backlog metrics. So here we are going to find the storage ratio metric that means how much of our effort is to deliver value to the end user or not. So right now, 68% of our work that is delivered on each iteration has a direct value to our end users. So we are kind of good. We could improve it, but we are good. We have the cycle time, that is the overall effort to complete a story, which is around 13 hours, which is not bad, but we certainly have a goal to go below that because a story is taking more than a day right now. Then we have the most hated backlog metrics of all time, velocity and volatility. They are discussed a lot in the web about how good or how bad they could be. We use that because we need to set our pace, and velocity and volatility, they are good for that. So velocity is the number of story points delivered, and the volatility is the standard deviation that we have between the last three iterations, right? So there are a lot of pros and cons on that approach, but since we need to set the pace and we need to be predictable, we use that in our work. The second half of our backlog contains compliance metrics and verifications. So here we are going to find our product maturity score, the customer satisfaction, metrics that measures how well we are doing to our stakeholders and our end users. We have code coverage, we have the DevOps maturity, and we have several compliance checks related to our cloud environment, service accounts, vulnerabilities in the source code. So with that, we have a whole view of what our team is doing and how well we are on that, on each aspect. So now let's go to the results. To measure our progress, we got the product maturity score that we have for our 5 products, and we have started to measure from the beginning of this year until now. When we have started our journey, our product maturity score was about 15% for all the products. Now that we are reaching the end of the 3rd quarter of the year, 4 of our 5 products, they have reached the goal of 70%, and we are still have the last quarter of the year to make sure that all products will reach that goal. And it's important to say that this product maturity score, it evaluates several aspects of how the team execute their work, and having reached this those high scores in just 3 quarters means that we were able to have a data-driven mindset really strong in the team, because we were able to work around the issues and to find the solutions really quick while we are working in 5 products. So it's really a good result. And of course, we need to list the benefits that we have with this approach. So I have listed here 4 benefits. The first is we have saved around 6 hours per week for our product manager. Remember that he said that only 5 minutes to collect the metrics? Yes, he was wrong, as usual. And every week, our PDM was spending 6 hours to collect all those metrics and work on them to show that to the team. Those 6 hours now, they are used to connect with the stakeholders and end users in a more frequent fashion, and also to increase our ability to solve problems. So we have more time to understand what we need, what the problems that we need to solve. We have increased the team efficiency in around 10% based on the story points delivered, meaning that we are more efficient in planning and how to estimate our efforts. We have improved our ability to assess performance and create action items by delivering ready-to-use measures. So this means that basically the dashboard have helped us to be more efficient in assess our performance and determine action plans. And also, I think it's good to mention the cultural change in the organization. The executives and other teams have started to look the metrics in a different way, because we are showing now that metrics doesn't mean that green is good, red is bad. So that you really can use those metrics to be as drivers for planning changes and planning improvements. And we have now 4 other teams that are following the same steps to create their own product team dashboards to set their pace in the digital transformation. And with that, I finished this presentation, and I hope that you have enjoyed to see how we can use a tool like Grafana in maybe a little different light. Thank you.
Hello. Hope you are listening me. I see a few questions coming up, so I will start to answering those. The first question is when you set out on the digital transformation journey you talked about, were these the results you are hoping for, or were you surprised by the results? Well, before the digital transformation journey, we have been using metrics to evaluate the team and all that, but we were not using those metrics in the way we are using now. So yes, when we first start to see the results of those metrics, we were surprised because we thought that our team was more mature, right? And we saw that even with experienced team, we still have a lot of to learn and to improve the way that we work. Do you plan on using predictive metrics, machine learning into product scores? That's a good point. We are still really early in the way that we are processing this information, so maybe we need to have a better thought on that. But would be interesting if at least we could predict our our deliverables every iteration. So yeah, it would be nice, but I don't know if we are on the point for that right now. What does your Grafana Enterprise Metrics deployment look like? Are there specific features that you are utilizing as opposed to... Well, that's a good question, because since I'm from a product team that uses Grafana as a service, right? Inside the company, I don't have any idea about how it's configured. I just entered in our digital cloud, as we call the Dell Digital Cloud software, to request a space in Grafana and request the usage of Grafana Enterprise Metrics, received the keys and all that to be able to set up, and that's it. I started using it. So unfortunately, I don't have anything to share in terms of Grafana Enterprise metrics. Okay, I see that we don't have any other questions. So thank you for the ones that have watched this presentation. Bye.
Hello everyone, my name is Kunarad. In this session, we'll be talking about distributed tracing with Grafana Tempo. So we have a lot of exciting new features to present during this session. First off, I will present our newest feature in Tempo, native search. Then Mario will talk about service graphs and how to generate them using the Grafana agent. Next up, Jem will be announcing Grafana Enterprise Traces. And finally, Joe will do a recap of this session and look a bit at the future of Tempo. At the end of this session, we will have a live Q&A. So if you have any questions during this session, feel free to enter them in the Q&A box, which you can find to the right, I think. But with that said, let's just get started. So the past few months, the team has been hard at work to add native search capabilities to Tempo. And we're really happy to be able to release this now with Grafana Tempo 1.2. This is what it looks like in Grafana. So at the left, you can see the new search view. At the top, you can specify your query. It will list a bunch of traces that match your query, and you can open them in the trace view as you're used to. So search is currently an experimental feature. So this does not mean that it is unstable. We have been using it internally for the past 2 months now, and we're also using it at scale. But it means that it is under active development and also quickly evolving. So what we show today is not the end goal of search. It's just a big milestone, but expect to see constant changes in this area as we add new features, new capabilities, performance improvements, etc. Search as it is implemented today allows you to search for recent traces using any attribute or tag present in this trace. So if you set a tag on a span, you will be able to search on this, but you can only search for recent traces. So traces have been ingested by Tempo in about the last 30 minutes. But yeah, with that said, let me just show you how it works with a quick demo. Okay, so we're now in Grafana on the Explore page with the Tempo data source selected. So this Tempo cluster is our internal cluster, which is currently ingesting near to 2 million spans per second. And what you'll see here is there's a new tab, search, in which you can, search Tempo. So you can just run a query without specifying any filters, and then Tempo will return the most recent traces. As you can see here, some of them don't have a root span yet. That's because the trace is being ingested at the moment the query happens. So it's really happening in real time. And the data we show is you have the trace IDs, you have the trace name, so it's the name of the root span. We have the start time when this trace was started, and we also have the duration. The duration is calculated based upon the earliest and latest span, and is a good indication of the duration of the operation it's linked to. Usually, you don't want to search just any trace. You want to start filtering down. So we have a couple of options here. So first of all, you can search on the service name. The service name is a tag attached to every span, which corresponds to the application or the component the span is originating from. So this will list all available service names in this cluster. And for instance, I'm just going to pick Tempo Query Frontend just because that's one I'm most familiar with. And then when you search again, you'll only get traces related to this service. Similarly, you can also search on the span name. So you have a couple of span names here already. For instance, the trace ID or the tag name. And you can also filter on these. So you can search, say, I want to have something with trace ID, select them, filter again, and yeah, the results are filtered a bit more. So let's take a look at one of these traces. So I'll just open this one. So what you can see here is a trace which is built up of a lot of spans. Those are all the little blocks. They have slightly different colors depending on the service they are originating from. And every span has a lot of metadata attached. So these are the tags or attributes, and they're added by the instrumentation code in your application. So these will contain useful information. For instance, this is an HTTP request. It will contain the URL, the status code and method. And a span will also have process attributes, which will indicate, in which cluster was this request happening, what is the pod name, IP address, etc. Now, with Tempo Search, it's possible to search on any of these tags. So for instance, if I want to search on HTTP URL, that's totally possible. So I can, for instance, take this URL here, put it in the tags box here, say Tempo HTTP URL has to be equal to this one. And then when I search this, I will get a single result because there's only one request with this specific URL. The tag matching here isn't an exact match, but it's a string contains. So what I also can do is I can just drop this last part, the specific trace ID, and only search for this part of the URL. And this will return all the traces that contain a tag HTTP URL containing this string. Like this. Another fun fact that you can do is, for instance, if you don't know the full span name, but you know that it contains something related to trace ID, you can just remove this here and say here name equals something containing trace ID, search on that, and it will be the same filter. The last filter option we have, you can also filter on duration. So you can, for instance, look for slow traces. For instance, I want to look for all traces slower than half a second. You can search on that. And these are longer than 1 second right now. So it's kind of weird. You can look into these and try to figure out, what's going on there. Similarly, you can use the max duration to only return traces that are shorter than a specified duration. All right. And that's all I had to show for this demo. So this is a high-level timeline of development of Tempo Search. We have now completed phase 1. So in phase 1, we implemented the initial search API and made it possible to search for recent traces. This has now been released with Grafana Tempo 1.2 and Grafana 8.3. In the next phase, we want to search all the data Tempo stores. So not only the last 30 minutes, but all the 30 days of data. So this is several magnitudes more data to search through. So it's going to be quite a challenge. But we already started working on this, and actually results are already pretty promising. Meanwhile, we're also working on a query language for Tempo, TraceQL. Similar to what LoQL is for Loki, we want to create an intuitive and powerful query language specifically designed for traces. So the end goal here is to create an easy and expressive way to query Tempo. But, more news about that later. And with that said, try out search today. If you're already using Tempo, you can update to 1.2. You just have to set the feature flag. If you don't want to run Tempo yourself, you can try it out in Grafana Cloud, in which it will be released very soon. That's it for search. Let's move on to Mario.
Thanks, congrats. Hi, everyone. My name is Mario Rodriguez. I'm a software engineer at Grafana Labs, and today I'll be talking about service graphs. But first, I will introduce the Grafana agent. Very frequently, distributed systems make use of a tracing pipeline that will upload the spans from your application, buffer them, and eventually forward them to a tracing backend. And the Grafana agent is that. It's a tracing pipeline. The Grafana agent is a push-based agent built using OpenTelemetry that can collect all your traces and forward them to Grafana Cloud or your tracing backend of choice. With the Grafana agent, we're able to leverage the information as it is collected to create additional metadata. And the latest feature that uses this technique that we've been working on is service graphs. So what are they? Well, a service graph is a visual representation of the different interrelationship between various services. They help us to understand the structure of a distributed system and the connections and dependencies between its components. Service graphs are built from metadata gathered from traces as they pass through the agent. Essentially, the Grafana agent will look for pairs of spans with client and server tags and use this information to recreate requests and build the edges needed to compose the graph. Data is composed as Prometheus metrics and pushed to a Prometheus compatible backend, where then it's served to Grafana. Service graph shows a view of the different services that comprise the system and how they're connected and communicate with each other. It also shows error rate and latency across the nodes. As you can see, you can filter by different tags. This can be very helpful to isolate nodes or specific paths in a large graph. And you're also able to link to the source data for further analysis. So what value do service graphs provide? Well, first, they allow us to infer the topology of a distributed system. It's not uncommon that as distributed systems evolve over time, they get bigger and more complex. And getting an overview of how different services relate to each other is not trivial. And service graphs can help with this. Secondly, service graphs can provide a high-level overview of the health of the system. Getting a complete view of a distributed system is very powerful. Service graphs are able to show error rates, latency, and other relevant data. And last but not least, they can provide a historic view of a system's topology. Nowadays, distributed systems can change very frequently, and service graphs offer a way of seeing how these systems have evolved over time. Finally, I want to mention a couple of things we're currently working on. First, so we're integrating time comparison of service graphs into Grafana. So this way, you not only can see how a system has evolved over time, but you can compare 2 points in time. We're also working on including more metadata about the system as a side panel, so you can get a quick grasp of the entire system. And lastly, I'm happy to announce that we're planning on integrating this feature into Grafana Cloud. So service graphs and other Grafana agent features, such as spam metrics, can be automatically generated and linked to your Grafana Cloud instance. That is all from me, and now I will leave you with Jen.
Hey there, my name is Jen Villa, and I'm a product manager here at Grafana Labs, currently coming at you from Rochester, New York. I'm excited to be able to talk to you today about Grafana Enterprise Traces 1.0, which we'll be releasing shortly. Now, to start from the beginning, what is Grafana Enterprise Traces? Well, you'll hear me refer to it throughout this presentation as JET. Yes, that is G-E-T, pronounced as JET, the plane. Well, first and foremost, JET is the enterprise-ready version of Tempo, our open source distributed tracing store. Now, what does enterprise-ready mean here? Well, what it means is you're going to get everything you know and love about Tempo, including all the great features you just heard about before my presentation, plus you're going to get the additional feature set that anyone deploying in a large, complex organization needs. All right, let's get a little more specific. What is that feature set that I'm talking about? Well, I'm going to focus on 3 areas in this presentation: security by default, fine-grained access controls, and simplified administration. All of these are going to come from our own experience running a distributed tracing backend as part of Grafana Cloud, as well as our experience working with large enterprises in the metrics and log spaces. All right, to help understand kind of some of these challenges that we've built features for, let's start from kind of what your day one setup looks like. Now, when you get started with Tempo, it's incredibly easy. You have a team, they come to you, they've started to instrument their applications to emit traces. Those go to a pipeline stage, be that the Grafana agent or the open telemetry collector, which then buffer those traces and send them along to Tempo. You then have a Grafana connected to that Tempo that you're using to read back the traces. Now, in fact, you become so successful with this setup that you suddenly have multiple teams coming to you and saying, hey, I would like to do the same. I would like to start sending my traces to Tempo and reading them back. Now, this can create some noise, right? Since everyone's traces are going to be going into the same bucket, and one team, say, spike in ingestion or in querying could degrade the experience of another. But not a problem. You know that Tempo, like Loki and Cortex, our logs and metrics backends, has multi-tenant support. So you can enable multi-tenancy on the Tempo backend. It's just one config flag. And then on the agent or the collector side, all you do is add a couple lines of config to send this HTTP header that you see in my slides, xscope org ID. Now that header is going to include what will be the tenant name, and Tempo will receive that and use it to determine where a data or a query needs to go. Now, this works amazing in a trusted environment. But what we've seen is that at larger organizations, this tends not to be good enough. Because with this kind of trusting setup, any entity can just throw whatever value they want into that HTTP header and start sending you spans. That data is then all of a sudden going to be in the same cluster as your production data. Furthermore, that data could suddenly start spiking the load on your cluster, increasing the cost or decreasing the performance of it. I've shown this right here as a bad actor, but it could also just be something as simple as a misconfigured agent. You have the same problem on the read side, right? Any Grafana can connect to your Tempo cluster, provide this xscope org ID header saying, hey, I want to read out the spans from team C or team A or B. This can be problematic because this way you actually don't know who's querying your trace data. And this can be an issue if there is potentially sensitive information with your traces. Really, what it boils down to is that with this approach, there's no actual way of authenticating that whoever it is that says, hey, I want to read team B is actually allowed to do that. Now, in open source, you could solve this yourself by building a gateway component that sort of serves as an intermediary layer and then does that authentication for you. But with Jet, we've gone ahead and done that for you, so you don't have to. You're going to get both an administrative API and a plugin that installs in Grafana that's going to let you create, edit, and delete tenants, as well as access policies for those tenants. What's nice about these access policies is they're a bit more fine-grained than just saying, hey, I just want access to team C, the tenant. You're actually going to be able to define what kind of access that is. Is it read? Is it write? Is it admin? Is it delete? In this way, you can actually determine that whoever's accessing the cluster is someone who actually has access granted to them. So now I'm going to take it over to the product and show you what that looks like. Alrighty, so you're going to see in front of you what is a window with a Grafana. And you're going to see that we have our Jet administrative plugin installed here. So what I'm going to do is take you through what it looks like when a new team comes to you and says, hey, I'd like to start sending metrics to your Tempo cluster, or in our case, a Jet cluster. So let's start with our display name here. So let's say this team, only for purposes of my name, is called Team Gen. I'm going to start by creating their own tenant, their own logically isolated piece of this cluster. What's the first thing I do from there? Well, they need to be able to send traces to the tracing backend. So I'm going to create an access policy to give them that access. I'm going to make sure the permissions that it gives you is the ability to write. I could do both write and read, but I'm going to keep it scoped narrowly. And I'm going to say, hey, that write access should be on this tenant, Gen. What's the next thing I do? I'm going to create a token with whatever name I want, leave it to not expire. And here's my token string, which I will copy. So what happens with the token here? Basically, any entity presenting this token, Jet will take that token, decode it, figure out what access policy it maps to, and then determine, hey, is this access policy, does it give the user or the entity the permission to do what they're asking to do? So what am I going to do? I'm going to take this token string. I'm going to pop open my terminal here, and I'm going to go in and look at my Grafana agent config. This is where the team, in my case, I have Team Jen here. This is where they would start sending traces from their agent to the Tempo backend. So what am I going to do? I'm going to paste in the token that I just created. And as my username, I'm going to put the name of my tenant. And from here, I can start my Grafana agent. What am I going to do first? I'm going to start generating a bunch of traces. And then I'm going to start an agent to listen to those traces and then forward them on to Tempo. So coming back to Tempo here. So what's the next thing I'm going to want to do? Well, I need to make sure that we can actually read those traces back out. So I'm going to scope a policy to read specifically to Jen's tenant, and I'm going to create that. And the next thing I'll do is I'll create a token for that read access policy. Now, what could I do here? I could take this token and use it to directly curl the query API of Jet. Or really more commonly, what I'll do is I'll use that token to enable a Grafana to have access to Jet. So we have actually a little shortcut here that I can create the data source with this token in here. And I'm going to call it something a little nicer here. And we're ready to update this and kind of hop over to the Explorer. So you'll see here I have a read gen, which is what I called my data source. And from here, this Grafana is actually authorized to read my Jet cluster for this particular Gen tenant. So how do I know that's working? Well, I can come over here to where I'm creating a bunch of trace IDs, take one of these trace IDs, and I'm going to query it. And here you see we have data back. Another challenge that large enterprises have to deal with is what happens when you're suddenly managing multiple Tempo clusters. Maybe you have multiple Tempo clusters because you have applications in one region and then other applications in another. Or maybe you want to run 2 Tempo clusters so you have redundancy. Now, of course, you can always query both of these individually and make them distinct data sources in Grafana. But one thing we've seen large organizations want is an ability to get a global view of data across the many clusters that they might be running. And so what have we done? We've gone ahead and built a Jet component called the Federation Frontend. So those of you familiar running Tempo and microservices, it'd be just one more service that you spin up using this target flag Federation Frontend. This component, then, when you hit it with the query, is actually going to fan that query out to whatever Jet clusters it's configured to talk to, and then it will put all the results back together, merging them and giving you one result. So you can issue one query and potentially talk to many, many Tempo clusters at once. So that was just a quick overview. Sorry, I only had 10 minutes there, but please tune in. We're going to be doing some more enablement, another webinar probably come January here. But overall, Grafana Enterprises Traces is going to be landing soon near you. Please stay tuned to our blog for the official release of the binary and the documentation. In the meantime, if you're looking to get started right now, take it for a drive on Grafana Cloud Traces. This is our hosted distributed tracing product. It's using the same software under the hood, but you don't have to have any of the hassle of managing or running it yourself. And with our free tier, you're going to be able to get up to 50 gigabytes of spans a month. So that's all for me. Thank you.
Hey, everyone. Thank you for joining us at the Tempo distributed tracing session. My name is Joe Elliott, and I'm a principal engineer here and the tech lead for Tempo and distributed tracing. I'd like to thank all of my previous presenters for an awesome session. Let's wrap it up here. So I think of all of the news, the thing I'm most excited about personally is Grafana Tempo 1.2, Grafana Tempo 1.2. Recent trace search is an amazing step in adding full backend trace search. We spent a lot of time exploring different formats and improving efficiency of storage of traces in order to better search and to eventually extend all of this code and all of this learning to our full backend. Additionally, Grafana Tempo 1.2 is the most performant version of Tempo that has ever been released. Somehow, kind of out of nowhere in the past few weeks, we'll look at that in a second, but is the most performant and fastest version of Tempo ever. We're excited about both of these things. To walk it back just a little bit, in June, we announced 1.0, and at the time we had about 74 billion traces, and our P50 was 2.2 seconds over that search space. And today we have roughly the same ingest, maybe a little bit less. This is on purpose. We didn't want to grow our ingestion because we were kind of working on this new feature and we knew our cluster would be a little bit more unstable internally. So we wanted to slow down our growth while focusing on searching the new data that's coming in. But our total traces went up to 121 billion. This is a 60% increase in the number of traces that are stored in GCS right now for us in object storage. And our P50 is actually down 60%. Our P50 is only 800 milliseconds. So our core Tempo product is actually storing more traces and searching them faster than it ever has before with Tempo 1.2. This is another very important graph. This is a graph that means a lot to us on the Tempo team. This is the bytes that Tempo receives over the amount of CPU it spends in order to ingest that. And the reason we pay attention to this is because CPU is the largest cost driver for running a Tempo cluster. So here we start adding trace search, things go down. This is expected. You're adding a new feature. It's not as performant. It's actually doing a lot more on write in Tempo when you have search enabled. And here it goes down again. We're continuing to add a feature at this point. Scary cats up to bat. We're not having a good time. Our performance is about half of what it used to be without search enabled. We didn't quite want this. We knew that adding search would have some kind of negative performance impact, but certainly we didn't want to, have the amount of bytes we could receive per CPU. So in the last few weeks, the team really got it together. We focused a lot on performance, and we really brought everything back. In fact, Tempo 1.2 with search enabled is the most performant version of Tempo ever. The cat is happy. The developers are happy. We hope you are happy. So with search turned on, you are still getting the most performant version of Tempo ever. With search disabled, you're getting an extreme performance increase at high loads. Or in the last few weeks, our performance has just gone through the roof. We found a few very powerful ways to increase performance. We're very happy with some of these changes. So to bring it all together, thank you to Kunrad for talking us through search, for talking about backend, or for our new recent trace search. Look for news soon, hopefully, on full backend search, where we're iterating over those 124 billion traces or whatever, trying to find specific conditions. Also, we're looking at building a new query language, a TraceQL query language that will hopefully allow us to express complicated conditions that we want to find our traces. Mario also brought us some good news about service graphs, a new feature in Grafana Cloud, as well as these metrics being generated in the agent. We've also discussed some upcoming improvements to service graphs, as well as putting service graph generation into Tempo proper, into Tempo open source proper. This will allow us to also offer it in Grafana Cloud directly, which will be more performant and will give everyone access to service graphs and won't require you to configure it in the agent. And then finally, Jen talked about Jet, our new enterprise tracing offering with new features like query federation. So you have multiple Tempo clusters. They're all receiving maybe millions or tens of millions spans per second. We can query across all of these, as well as Jen also talked to us about the authentication and authorization options available in enterprise Tempo. Thank you everyone for attending this session. We're so excited about Tempo here. Please try to get involved. We have the Grafana Slack channel. In our public Slack, there's Tempo, there's the repo, the Grafana Tempo repo, and there's also the community forums. All of these are great ways to reach out to us, to ask questions, to chat about features, to get connected to the Tempo community, to help build a product that we all need, that we all want. And we are excited to kind of be a part of that and help us all create a distributed tracing platform that works for all of us. And thank you all for showing up. I think we're going to live Q&A next. We'll see you there. Hello. Hey, everyone. Hey, everyone. Glad to have you all here in the Tempo session. We're going to do some Q&A real fast. Before we get started, I want to announce there's a community call tomorrow. Please come join. If you go to that Slack channel mentioned a second ago, #Tempo in Grafana Slack, we'll announce it there with a link to the community call. So please jump in there with us. So to get to the... Oh, sorry, what's that, Kunrad?
It's on Thursday.
Oh, today's... Thank you. It's Tuesday, isn't it? I thought it was Wednesday. It is on Thursday. That's correct. To get into the questions, so we can get it through as many as possible for y'all. The first one is a search-related question. Min duration means min duration of a span, not for the whole trace, right? Similar to Jaeger. I'll let Marty answer this. Marty was the lead engineer for the search feature. Him and Ananya and Kunrad all worked on that. So how does min duration work for a trace search?
So in this release, in this feature, we've gone with a trace-oriented approach. So in this case, the min duration actually is at a trace level. I mean, we understand there are limitations. If you have certain sampling rates or a deep kind of like call chain, that may not be great, but that is something that we'll address in the future, kind of like the long-term plans for what we want to do for the more powerful query language and storage and everything.
Cool. Is the plugin and administrative add-ons for Tempo for the tenant stuff also integrated in Loki in the near future? So is some of the similar enterprise level features that we announced for Jet also available in Loki? Jen, do you want to handle that one?
Yeah, sure. So the demo that I showed, all of those pieces, we do have them in our enterprise version of Loki. So it's not in the Loki open source, but it's in our Grafana enterprise logs, which we actually released earlier this year. So just head over to our website and take a look. We actually reused a lot of the same design patterns that we have for tenant management and authentication already in our enterprise metrics and logs products, and we applied those for Tempo to build Jet.
Cool. Next question is another search related one. What's the difference between doing a search on a span name in the field, I suppose, and using name equals in the tag search field? I think there's none, but I'll let Marty answer that one too, in case I'm wrong.
Yeah, there's none. The UI is just making it a little bit easier to filter on what we thought would be the most popular attributes of spans, which are the service name and the span name. There's no difference. So the name is actually a tag in the data underneath. That's why it shows up.
Cool. When will search be available in Grafana Cloud? Kunrad's been an engineer who's been instrumental in search, and he's also spent a lot of time helping us getting it live in Grafana Cloud. Can you answer that one for us?
Yeah, so search will be rolled out together with Grafana 8.3. So once your Grafana instance is updated to 8.3, the feature toggle will be enabled automatically, and then you can search Tempo.
Cool. 8.3. Soon. TM.
Very soon.
That's right. New search in Tempo is great. It is great. How do we turn on the feature in Grafana plus Tempo? I think we have a link for that in our docs, and there will be a blog post going out tomorrow about announcing Grafana 1.2. And in that blog post, it kind of goes over the major features in 1.2, including this new search. And in that post, you'll find a doc, or you'll find a link to a doc that describes exactly what feature flags you need, both in Grafana and in Tempo. Also, you could come to that community call. That's definitely on Thursday. That would be another way to find out how to turn the flags on. How to handle asynchronous API calls behind a pub sub mechanism to keep span dependencies inside the same trace. So that question would be kind of better suited for perhaps an offline chat. There's definitely a lot of resources online, like if you want to pass some kind of message through Kafka or through Rabbit or any of these other queuing systems. You basically just have to attach a small amount of metadata. And if you want to chat in the Tempo channel and ask a question like that, I could probably point you to some links and some resources that would help you start to understand what it takes to do that kind of a hold context through an asynchronous queue. Cool. So Tempo 1.2 with search enable is less performant than Tempo without search enabled, but both are significantly more performant than Tempo 1.0. Is that right? That is right. Right, we were like I was kind of showing on the graph, the performance was not great for a long time, and then towards the very end, we did find a few performance gains, which actually gave us a whole lot back. And 1.2 with search enabled is more performant than 1.1, and then 1.2 without search enable is about twice as performant, which is awesome. Will Tempo federated tracing be available to the open source community? Jen, can you handle that? Bad news.
Yes, I was like, probably not the answer you want to hear, but right now this is only a feature of our enterprise product. We have a similar feature in our enterprise metrics product, and looking forward to bringing that to the enterprise logs product as well. But that's at least the line for now. Who knows? Things may change.
We use influx. Can that be used for service graphs? Mario, you spent most time with service graphs. Can you answer that question for us?
Yeah, sure. So what we do is build metrics, and we expose them as Prometheus metrics. So unless there is a way in which you can scrape Prometheus metrics and somehow translate them to influx, at the moment there is no support for other formats for metrics.
Prometheus remote write is fairly well supported. I think influx might support it itself. Do you know offhand? Like most third-party vendors do. I think at this point it's so popular that a lot of these open source databases do as well. So yeah, if you just search for remote write support, you'll find a long list. Sorry, Mario, did you have something to add there?
No, if that's the case, then definitely, yeah, you would be able to use influx.
Right. I found it surprising the last time I looked at it. The list was longer than you would expect. A lot of people support remote write. Cool. Is the phase 2 search expected for V1.3? Marty can handle that, yeah?
I would say, yeah, generally, I think that's the plan. Exactly what shape or form that comes out in, or to what extent, there's a lot of things we're looking at. But yeah, you should expect more search enhancements in 1.3 for sure.
Cool. I'd say our goal is generally for the next quarter to have full backend search available. If that's 1.3 or 1.4, I don't know. We've internally been talking about maybe ramping up our release schedule a little bit. So maybe we do a faster release in order to get some bug fixes or other changes or small features. I don't know. Basically, I'm not too worried about 1.3 in terms of releasing full backend search, but definitely the next quarter, that's the focus of the team. How is Tempo for tracing and Loki for I have no idea how they're different from New Relic. Feel free to go look that up. My company runs their workloads on AWS, and we're considering either X-Ray or Tempo to monitor tracing. What pros does Tempo offer? I'm not totally familiar with all of the feature list of X-Ray, but Tempo in particular would be, the goal of Tempo is to be a very inexpensive, high-performance solution to bulk consume and store and recover traces by ID, and now we're searching them as well based on these tags. And then of course we have the search coming up, more complete search, maybe TraceQL or some other kind of like query language. We have service graphs coming out generated on our side, and a lot of features in mind for that for Grafana, as well as some of the other features we mentioned today. And I think that's all our questions. Does anybody have anything else to say on our side? We have 3 minutes left. That's what they tell me.
The only thing, Joe, I'd add to your last answer, also not super well versed in X-ray, but just to call out that, yeah, Tempo can run on kind of any public cloud provider. So, one nice piece there is just some flexibility in case your company ever decided to use a GCP as well. And it's compatible with the object stores of all of these cloud providers. So you can use Google Cloud Storage, AWS S3, or Azure Blob Storage. So that's all I'd add on that one.
Cool. Thanks, Jen. Thank you all for attending. It's been fun. Please join us on the Tempo Slack, or we have the GitHub repo. There's the community forums. There's tons of ways to get a hold of us and start a conversation and kind of get involved with Tempo. And in addition, community calls on Thursday. Please join, and we will go over a lot of what's good in 1.2, maybe discuss a lot of what we've talked about here as well. And you can have a more direct forum for questions, and it'll be a smaller affair, I think, but it'll be fun. All right, everyone take care. I will see you all when I see you.
Hello, my name is Rob Gustafsson. I'm the CEO at K6, and welcome to this session where I will be joined by my colleagues Nicole van der Hoeven, developer advocate at K6, and Olha Yevtushenko, software engineer with the K6 open source team, to present about K6 and Grafana stack in regards to load testing. So I will start off by introducing K6, what it is, why we built it, and give a short demonstration of how you can use it. Olha will then take us further, showing how K6 can be used with Prometheus remote write compatible solutions. And Nicole and I will then finish off with an announcement and a demonstration of an exciting new capability coming to K6. All right, so what is K6? So K6 is an open source testing tool with a focus on load testing. We decided to build K6 roughly 5 years ago because we weren't satisfied with the user experience provided by the existing load testing tools in the market. We wanted a tool that would be used by developer-like personas and not only testers and QA engineers. So we knew we needed to build a tool that had a test as code approach, a tool that you scripted your test cases in a familiar programming language to both testers as well as developers alike, which is why we chose JavaScript for K6. We also knew that the tool needed to work really well in the modern software development lifecycle, where all kinds of code, application, test, infrastructure, observability even, is stored in version control systems, and then you use CI, so continuous integration, for automating various aspects of quality assurance, deployments, etc. And ultimately, your code, your systems end up in some sort of cloud-native hosting environment. And we wanted the tool to be compatible with existing tooling in this larger cloud-native ecosystem. And we also wanted to make sure that we helped shift testing to the left as part of this, right? And in extension, also shifting observability to the left. But what does that mean? Well, to us, it means that K6 adds a proactive dimension to observability, allowing teams to find and fix performance problems earlier in the software development lifecycle in pre-production, so further to the left, where it's less costly to fix them. So how do you achieve this? Well, you use K6 to generate virtual user traffic towards a pre-production version of your system, as opposed to the real traffic your system sees in production. You then observe the pre-production system to understand how it responds to the traffic stimuli by looking at your metrics, logs, and traces. And if you have SLOs, well, even better, then you can see if your tests would potentially breach an SLO if the system were deployed to production. You can take this one step further by automating this process, incorporating it into CI, allowing teams to understand if a system change would potentially introduce a performance regression into a production environment where it could cause a costly incident. With that said, let's jump into the first demonstration out of 3 in this session, where I will be demonstrating how to create a test case in K6 and how to execute it using the K6 CLI. All right, I'm in my editor now, so let's have a look at a simple K6 test case and how we can execute that using the K6 CLI. So typically every test case has at least these 3 sections. The first one is imports, so we can both import native K6 modules and APIs, but also any custom JavaScript modules that you might have with reusable test logic and options. The second section is the test options, and the third one is the test logic that the virtual users should be executing as their spawn. And we spawn virtual users by specifying how they should ramp up over time, so how the concurrency should ramp up over time. And the simplest way to do that is by using the stages option. So the stages option is a list of steps. We only have one step here. The first step is implicit. It starts at 0 virtual users. and then it ramps up to the first target here that we specify in the first step. So 10 virtual users concurrently in this case. And this ramp up from 0 to 10 happens over the course of 15 seconds, and it's a linear ramp up. In this case, we also want to specify some performance goals, and we do that by using the threshold option and functionality in K6. And we specify these thresholds by first selecting a metric. In this case, we're going to use the HTTP rec duration metric, which is the response time metric in K6. And then you specify one or more conditions on this metric. So in this case, we're saying that we want the 95th percentile response time to stay below 1,000 milliseconds. Let's now have a look at the test logic. So down here we have the test logic. In this case, we're just making one HTTP GET request to this URL here, which is a test website. It's a WooCommerce system. And we're just fetching the front page HTML document here. And one thing to note is that K6, being a protocol level tool, only fetches the actual resource that you specify, right? So if you want to fetch any images, style sheets, or JavaScript files referenced within this page, you need to explicitly request those as well in your test case. We get this response object back. We pass that into this check function, and the check function is like an assertion function. So it allows you to have one or more sort of functional checks. So we're just going to make sure that the status code for this response object is 200. And then finally, we have a sleep statement of 1 second. And this is just to give some pacing to the virtual user so that they don't too aggressively loop over and over in this function. All right, let's now have a look at the K6, or how to execute this test using the K6 CLI. So we just execute the K6 command line. We see some available commands here. We're typically only going to use the run command and perhaps the cloud command if you use our SaaS service, K6 Cloud. We're just going to use the run command here. So let's run K6 run, and then we point to our JavaScript file, demo.js. And optionally, you can also override some settings here on the command line. So I'm going to override the virtual user ramp up and specify that I only want one virtual user, and I only want that virtual user to run one iteration through the test logic. So let's execute this. We can see it's executing in local mode, which means it's executing on my machine. Here we have some results printed to my terminal. We can see here that the check that we had specified succeeds with a green check. So the response status code was 200 as we wanted. Down here we have the metrics that K6 collects by default. We're going to focus on this HTTP rec duration metric because we had a threshold defined on this metric. And we can also see here next to this metric name that we have this red cross, which means that the threshold in this case failed. And we can see here when we look at the statistic that 95th percentile is way above the 1,000 milliseconds that we had specified in our threshold. So not shockingly, the threshold failed. And since the threshold failed, we can see here that the exit code as displayed down here in my terminal is non-zero, in this case 99. So if this test was run as part of a CI or automation pipeline, this would have failed that pipeline or CI build and hopefully notified someone that would have done something about it, right? And with that said, I'm going to hand over to Olha, who's going to look deeper into what we can do with the metrics that K6 outputs and some more advanced test cases. Over to you, Olha.
Thank you, Robin, and greetings to everyone. I'm one of the engineers of K6 open source team, and I'd like to tell you how we are extending support for Prometheus at K6. Why I say extending? Well, because we actually do have some support for Prometheus, but only in cloud solution. With this work, we'll have that support in open source as well. I must note here that I will be primarily talking from perspective of load testing with K6, but this work can be used for other types of testing just as well. So to give you some context, let's see how the problem may look like from perspective of K6 user, the problem that Prometheus might help us solve. Here you can see a sample script for K6. It is written in JavaScript because that's what we use. It is very simple, but to understand it fully, you must know such a concept as virtual user. So virtual user is an abstraction of real user who performs a certain action, and that action is what we are trying to load test. So in this case, you can see an implementation of default function where we get a web page and then sleep for a bit. That is an action of virtual user in this script. Since such an action can be performed more than once, each time it is performed, we call it an iteration. We must also check how we set up global object options. Here we set up that there will be 800 virtual users and they will run for 5 minutes. They will try to perform as many iterations as possible within that time period. So what we will see once we run this script? We'll get this kind of output in command line. You can see that this test has run for 5 minutes 30 seconds, and that is correct. We set it up for 5 minutes, and 30 seconds is the so-called graceful period, which is given to virtual users to interrupt whatever iterations they are running at that time. Then you can see a bunch of numbers, like how much data was sent and received, the HTTP timings, iterations, virtual users. If you look, for example, at iteration duration, it shows that average is about 36 seconds, while HTTP request duration average is about 34 seconds. So they are rather comparable, and that is correct in this case, because in each iteration we are just getting one web page, making one HTTP request, and then sleeping. However, let's look at the HTTP request failed, and we can see that there are 11% of failures. Depending on what kind of performance we expect from our website, that may not be what we want. Can we understand why we have such a large number of failures? Well, from this, not really, and that's where metrics come in. So metrics are values that are behind these summary values. They are generated by K6 engine at the rate of once per second and regularly sent to outputs. Output is an interface, and we have more than one implementation for an output, and we plan to have many more. But let's note some of them. We have CSV and JSON, that's outputs to local files. We have REST APIs, that's an output to local endpoint where you can look up metric values during the test run. Then, somewhat differently, we have a cloud output, which is used by app.k6.io. Cloud solution has its own storage of metrics, processing of metrics, and even viewing of metrics. Then we have a Kafka extension, that's another output, and some others. And now we are also adding output for Prometheus. So how does it work? Well, it works with remote write. Remote write is an interface that allows you to push metrics to the given endpoint. Here I deliberately put remote write endpoint and remote agent as separate entities, because depending on your setup, they can be one entity and can be separate. Remote write is not actually tied to Prometheus, despite its name, and it can be implemented by anyone. But K6 doesn't care about this setup, it cares only about remote write endpoint. We must note that remote write feature has experimental status. However, there are 28 official integrations as of now, and there might be more by the time you are watching this video. Remote read is not guaranteed, so even if your remote agent has support for remote write, it doesn't mean that it will have support for remote read. We must also note that this solution is made as an extension to K6, so it must be built with our tool xK6, which allows us to add plugins to official K6. You'll see how it looks in my demo a bit later. Since remote agents are often tools that are rather popular in observability space, there is a very good chance that Grafana will support the remote agent. So then you can visualize K6 metrics in Grafana. I will show you how it can be used in my demo with local instance of Grafana, but the same can be done with Grafana Cloud or Grafana Enterprise Metrics just as well. And a couple of notes on implementation side of things. Remote write differs from exporters and scrappers in the way it handles time. So when you set up a scrapper job for Prometheus, for example, you don't need to worry about time. Prometheus takes care of it. But with remote write, you must send timestamps explicitly with values. And that can lead to a bunch of problems. Another side of remote write specification is that it is a very simple interface at high level. It just accepts a bunch of values and timestamps. And that leads to a problem of understanding between sender and receiver what those values mean. And that's how we come up with the concept of mapping of metrics. That is how we are going to map metrics from K6 to whatever remote agent we are sending them to. The simplest way is to send them as they are produced, and that's what we call raw mapping of metrics. We also have support for Prometheus mapping. So when we map metrics in K6 to metrics in Prometheus. K6 has 4 metric types, that's counter, gauge, rate, and trend. Counter and gauge behave similarly to counter and gauge in Prometheus, so we map them directly. Rate is also rather simple because it is a measure of percent of successful events. So it can take values from 0 to 100, it can go up and down, and in this way it behaves kind of like a gauge. And trend is the most tricky one. It allows us to see how statistics of values change in time. You saw in summary that there were 6 values: average, minimum, maximum, median, percentile 90, percentile 95. So right now we send these 6 values as gauges, because that's the best we can do. Prometheus has support for histograms and summary, but they don't allow to store trend as it is. However, there is hope. Prometheus is working on feature for sparse histograms. And once that is done, we will probably review our implementation of trend mapping and perhaps update it. And now let's look how this all works in the demo. In this demo, we are going to use a simple setup with Docker Compose, where we have an instance of Prometheus and an instance of Grafana running together. They're basically using default settings, except enable feature. Since remote write is experimental, it must be enabled explicitly, otherwise it simply won't work. For the sample test, we will use this website. It's a K6 website for testing. It's a fake shop. So we can imagine a scenario like this, that there was an advertisement for sale and users start to come in, they look at the first page, they look at the second page, they pick some item, and then they figure out that they need to increase the quantity of that item and then increase it to 2. So that's the scenario that is written here. Each of these functions is basically just a get or post request and a sleep bit after each of them. There's load page assets, so there are assets loaded, like CSS scripts, images. All of them are written somewhere here, just hard-coded, and all of them are loaded here. And our setup runs 10 views for 2 minutes, 20 views for 3 minutes, and 30 views, and then 50 views. So in total it's 10 minutes. That's a bit a lot, so I'm not running it right now. I have run it prior to this demo. And we'll just show you the result in Prometheus and Grafana. So first, let's make a note about how we are running. Here is how we built our K6 with output Prometheus remote extension. And here is how we run it. Here is the command. This is the most important argument, of course, URL endpoint. After we run it, we would have had this kind of summary with some errors before that, like request timeout. So let's see now the same thing in Prometheus. If we start writing here, K6 underscore, we'll see a bunch of metrics. So we can see all of metrics that are built into K6. They are all 4 types: trend, rate, gauge, and counter. And they are in Prometheus now in this form. Of course, Prometheus is nice and all, but we know that Grafana UI is more versatile. So let's go to dashboard that we prepared. If we open global metrics, let's switch off refresh for now. So global metrics are basically virtual users and maximum virtual users. That's the metric that doesn't have any tags because it is kind of global for the whole test run. And we can see how the value was changing from 0 to 50, as we would expect, and the same is shown in the plot. That it went to 50, then it fell down a bit, and then we probably didn't get any new values, and that's why it is shown as stuck at 47. So these are global variables. Then we can go down one level and see scenario level metrics. Let's increase it, interval 1 minute probably is fine. So we can see bytes received and sent. It probably makes sense that we get mostly received because we are not uploading anything. We can see that iterations is rather small for 1 minute especially, but we should remember that there were probably dozens of HTTP requests per one iteration. So we can see here the iteration duration. So most of them are somewhere around 2 minutes, but some of them went more, and in maximum duration we can see 7 and 8 minutes. So that's a lot. Obviously we had problems. And in the full plot of all values for iteration duration, we can see that maximum, this one, started to rise somewhere on 8 or 9 minutes of the test run. Now if we go to the scenario, we'll see that on 8-9 minutes we started to increase from 30 to 50 views. So that's probably the reason that we are getting this kind of values, right? Makes sense. These metrics are already tagged. So tags from K6 are being transferred to Prometheus labels almost exactly, although they are an important exception. They can also be switched off, and then you'll have metrics without labels. But here we don't use it. So scenario level metrics can be filtered by scenarios. If I had more than one scenario, then I could have filtered them by that label. If I go down to HTTP, here I have requests per second. I have failed request rate. So we can see that at first for about 4 minutes we didn't have any failures, and then we started to have them, and it increased and increased. We can see what kind of response times we get. Here, successful and failed. Failed are longer, which also makes sense. The interesting one here is the HTTP breakdown. So we can see that when we started having problems, most of the time was taken by waiting. So we're waiting for the response from the backend, obviously. And we can probably see where exactly those problems started. They started earlier than 8 minutes. We didn't feel it as much as that, and earlier than we had started having failed requests. We can see it here. Then here we can see some requests by URL. Also must note that these metrics for HTTP, they can be filtered also by URLs. So I can do this and then see the metrics only for this URL. And they are filtered by method, post or get in this case. Now let's see the errors. The errors is an interesting metric. So here it is shown as a pie chart because end of file is a rare error, but we got it here. So here we must ask why some requests got end of file and some requests got request amount. That kind of question can be answered with tracing, and here I want to make a small advertisement that K6 team is working on integrating tracing into K6 solution. So stay tuned for our updates. It would allow you to see how request fares during its whole journey end to end. But back to metrics for now. So all of this information, of course, allows us to reason and analyze our test run much more than before. But we can improve it more, since these are just built-in metrics. They come out of the box with K6. But we can add our own metrics, custom ones. So let's do that. I have prepared a similar script, which just has, with the only change here are these two metrics. So one for response body size, and another for request per iteration. Obviously, each iteration can last different number of requests. So let's try to measure that. These are measured on each response, successful response. I will toggle it on here. And let's start it. So this script is called differently, custom. We'll start running it. On each successful response, we'll increase its body size and increase a number of requests per this iteration, taking iteration as a tag. So here is the metric defined with the tag iteration. Let's see that in Grafana. It already started running, so we can add some plots. So this would be, I think, response body size. I wrote wrongly. And let's add the second one. They're already here, so they are picked up rather fast. Let's switch on 5 minutes and refresh. This is basically real time, or almost as good as. So you can see that how requests change. In the meanwhile, we'll see how some iterations get stuck. And it's all in real time. Now imagine if you had your backend or website or something, whatever you're testing. You had the dashboards there in Grafana. Then you could combine those dashboards and this dashboard and then see the picture in full. And perhaps that would have helped you to solve your load testing problem. So we can see that some iterations start later than the first one. So the first one, then the second one, then the third one, and so on. And here the first iteration, the green one, started to get stuck. So it didn't go more than that in requests, so it started to fail somewhere here. We can try to trace why with all these metrics and adding new ones and so on. So this kind of functionality, of course, allows us to speed up our analysis quite a bit. And with that, I would like to wrap up this part and let's think about what happens beyond backends. So I'm passing the word to our developer advocate, Nicole.
Thanks, Olha. As a performance tester, I think that there are many aspects of application performance that our load tests may not measure. For starters, there's more to load testing than backends, and there's also more to performance testing than just load testing. Most people equate load testing with performance testing, but there are actually two categories of performance. There's front-end and back-end. Front-end performance testing verifies user experience at the interface level, and back-end performance testing targets the underlying servers of an application. And load testing is a kind of back-end performance testing. So there's actually quite a bit of performance that traditional load testing does not even measure. In web performance circles, there's a performance golden rule that says that 80 to 90% of the end user's response time is spent on the front end. This is something that was coined by Steve Souders. The implication is that we should start with front-end performance testing because a large part of the real and perceived slowness of a web app is caused by time spent in the front end. However, the golden rule can very quickly go inverse when you're adding some traffic to your back end. We see this all the time at K6, and that's the reason that we've, until now, chosen to focus on back-end performance. Through all the years that we've been in business, we've gotten countless of questions on how to measure and report on the end user experience while the back-end system is being load tested. And we've politely said that we've been focusing on the back-end load testing use case. But now that K6 as a tool has grown up a bit, maybe it's time to finally take the leap. Today, we are officially announcing the first public beta release of XK6 Browser Automation for K6. XK6 Browser is an extension for K6 that adds support for browser automation. On the left is what an XK6 browser testing script looks like, and it should look familiar to anyone who's used other browser-based tools like Puppeteer or Playwright. It's still in JavaScript, like K6, And it allows us to program interactions with DOM elements, such as clicking on a button or typing on a text field, rather than scripting the underlying requests, like HTTP requests. You can run the script headlessly, or you can view the web app within the browser as the script executes, as shown on the right. I'm personally extremely excited about this for 3 reasons. For the first time, we have a single tool for both protocol and browser level testing. No more refactoring or attempting to link 2 very different tools together, or having to cross-skill in multiple scripting languages just to get these 2 different types of testing in the same execution. Now we can write one test suite or even one script and use it for both protocol and browser level testing. And with that mix also comes the ability to test both the front end and the back end of application performance. So just think of seeing network metrics or response time alongside front end metrics like first contentful paint. XK6 Browser even excels in situations where protocol-level tools or traditional load testing tools can't be used, such as for single-page applications where there are client-side scripts that drive the application and there might not be any protocol-level traffic for every action. It's also good in situations where protocol-level scripts are possible but infeasible, like sometimes there are apps that require really complex correlation and view states and all that. And the best part is that it works with all of the core K6 features that you already know and depend on. So lightweight execution, extensible code base, the rich integrations, and developer-friendly APIs. Here are some of our goals for XK6 Browser. The first is that we've prioritized stability over pretty much everything else. We hate flaky tests. We think that XK6 Browser should just work and be very consistent. This is the same philosophy that we've always had with K6 as well, and we're extending it to XK6 Browser. XK6 Browser already works with existing K6 functionality, so things like multiple scenarios or being able to choose different executors for those scenarios, adding thresholds, custom metrics, and even output formats. We're not reinventing what already works, we're building on what we've proven to be functional. And we also want to expand test coverage. Many teams already have been using K6 for functional API testing, but now with XK6 Browser, they'll be able to use K6 as well for browser automation testing, and also front-end performance testing as well. XK6 Browser has rough API compatibility with Playwright, so if you're already using that, you'll be able to get started with XK6 Browser with very little downtime. It's also based on the Chrome DevTools protocol and will initially support Chromium-based browsers. Just like K6, it's built in Go for performance, and the scripting is going to be in JavaScript, which is pretty ubiquitous for developers and testers alike. I know you want to see more, so here's Robin, who will show you XK6 Browser in action.
Thanks so much, Nicole. I'm very excited about this announcement. Browser-level APIs and capability in K6 is a feature that has been requested for a very, very long time. So we're very excited to finally announce this public beta so that we can get some more of our users to try out this capability in K6 and give us feedback. So in this last demo session, I'm going to demonstrate how you can use XK6 browsers, what the APIs look like, and how they integrate with the rest of K6. So let's have a look at this test case I have here in my editor. So this is going to be a variation of the test case used in Olha's demo, but I'm going to use browser level APIs rather than the protocol level APIs that was used in her test case. So first of all, XK6 browser is an extension to K6, right? So you need to have a custom built version of K6, including this extension. Once you do, you can just import the browser module from K6-X-browser, and then you have the browser level APIs available to you. If we start off here by looking at the options, we have very simple configuration here. So we're going to use just a single scenario, a single virtual user executing the default function in 2 iterations. And we're going to keep the same threshold that we had in the first demonstration. So looking at the response time, and we want the response time to be less than 1000 milliseconds on the 95th percentile. And this works the same way as with protocol level APIs, because we hook into the browser and collect the HTTP metrics as the browser is issuing requests and receiving responses. So it works just the same way. All right, if we have a look at the test logic down here, we start off by using the launch method on the browser module to launch the browser, and XK6 browser works with Chromium-based browsers. We specify that we want the browser to be launched in a non-headless mode, which means we're actually going to see the browser Chrome, which is more exciting in a demonstration like this. And we're also saying that we want some slow motion to be added to the input actions so we can better follow what's happening inside of the browser. We then create a new page, meaning we create a new tab inside of the browser. And then we start executing our 3 different steps here in this scenario. So the first step is navigating to the home page, and we're going to use, as I mentioned, the same test system that's been used in the previous 2 demos. So this WooCommerce system available at ecommerce.test.k6.io. We instruct this action to wait with completion until we see no more network traffic, so until the network is idle. And then we continue to the second step here, add to cart. And in this step, we are going to look for a list item in the product listing on the front page for the product with the ID 24. So we use this DOM query here. And we're then going to look for the add to cart button for this product listing by issuing a query to that product listing item sub tree. And we're then going to click on this add to cart button to add this product to our shopping cart. And we know this triggers an XHR request in the browser. So we're going to wait for that XHR request to complete using this wait for selector method here. And we know that once the XHR is completed, it adds this class name to the anchor element, which is why we have specified this specific selector here that we're waiting for. So once that action is complete, we go to our last and final step here, which is a navigation to the cart page. And again, we wait until the network has gone idle before continuing. And the second action in this step here is to use this evaluate method on the page object, which allows us pretty neatly to execute this JavaScript function inside of the browser. So this JavaScript code is going to get serialized and then executed inside of the browser, and any results that come out of this function is going to be fed back to K6, so you can use that in subsequent actions. So what we're doing here in this JavaScript function here is we're going to query the DOM. We're going to find this cart item representing the product we added in the previous step, and we're going to look for the quantity input field here, and we're going to change the value from 1 to 2. All right, and then we're going to finish off this last step here by taking a screenshot of this cart page so we can also verify that the quantity has actually changed to 2. Right, and then we close the page, we close the browser, we sleep for a second, and then the virtual user is going to do the same step of actions once more because we're running this in 2 iterations. All right, let's now head over to my terminal here so we can execute this test. So we're going to see the browser Chrome pop up here, and it's going to start executing the steps, right? So first navigating to the front page. Second step is finding this product listing, and then we're clicking on the add to cart button, waiting for this XHR to complete. Then navigating to the cart page, where we're going to manipulate the quantity input field, and then taking a screenshot. And then the virtual user is going to start over, do the same action twice. So again, navigating to the front page here, finding the product item, clicking the add to cart button, wait for that action to complete. navigate to the cart page, modify the quantity, take a screenshot, and finish. All right, some interesting things to note here in the output to my terminal now. So we can see some log statements here. These log statements are actually coming from the browser. So we're collecting the logs that are executed as part of making console.log statements, for example, in the browser. They're funneled into the K6 logging system. And down here we can see the metrics collected by K6. And we see the HTTP metrics here because, again, we hook into the HTTP subsystem of the browser to collect these metrics as it's issuing requests. We also have some browser-specific metrics here. We collect these DOM content loaded event metrics, the loaded event metrics, and 3 different paint metrics as well. We can also see here that we had this screenshot right in the last step. So we can see that the quantity field was actually changed to 2. So that action was completed successfully. And with that, I'm going to end this demonstration. So if you have any feedback when you start using this, I know the XK6 browser team is eagerly awaiting any and all feedback they can get. It's a team that we branched off from the K6 open source team. So they are looking forward very much to taking this project much further and want feedback on it. So with that said, I want to thank you all for joining this session. Myself, Nicole, and Ola had a great time taking you through this K6 introduction to load testing with the Grafana stack. If you want to learn more about XK6 browser or download it to give it a spin, please visit our GitHub repo at github.com/grafana/xk6-browser. And if you want to learn more or join in the conversations around K6 in general, please join our community forum or our community Slack channel. Thank you so much. Bye-bye.
My name is Matthew Churcher. I'm a quality architect at Vonage. Quality architect just means that I work with a number of teams with their testing needs, strategy, and tooling. Before that, I was a performance test engineer for over 15 years, and I worked with the site reliability engineering team on monitoring and metrics for teams. That's how I came to be involved with observability. Once you realize companies really scaling, you realize that metrics and monitoring and production are very important along with performance tests. Today, I will be talking about building performance tests into your CI pipeline with K6 and Grafana. So first off, why have performance tests in your CI pipeline? We'll also be asking why K6, and we'll be looking at GitHub Actions and an example of Kubernetes. So why performance testing a CI pipeline? There's an adage, if there's no test, then it's broken. That applies to functional tests, but it also applies equally to performance testing. If you're writing an application that has critical performance, latency requirements, or reliability requirements, that you don't have too many errors, if you're not testing that regularly, you can't be confident the changes you've made haven't affected your application. Another reason is speed is becoming the most important competitive advantage for software companies now. By testing early on your pipeline, you find bugs sooner, and it's been shown that bugs are cheaper and quicker to repair if you find them sooner. It's more obvious which change in your pipeline, which commit broke the software, and where you need to be looking to resolve that, opposed to if you wait to a traditional waterfall approach and you've got a huge change list, then you've got lots of commits to go through to work out what broke. Also, the industry is looking to shift left of the testing. That's part of the move to Agile. So instead of waiting for the traditional waterfall development where we have an application that's nearly ready and we hand it over to testers to do performance testing and then find about all the defects at the end, we're looking to do that sooner. We're also looking to move more of that into the team. So we have developers and testers in the team working on performance tests, not just external consultants and specialists. So why K6? So K6 is a relative newcomer to the open source performance testing tools, has amazing performance compared to some other tools. I'll be showing you some benchmarks shortly. And it plays really well with CI, CD, and version control. WAS has a relatively simple JavaScript API, again, very friendly for developers, but also testers, and it's a simple command line interface, so you can easily add it to your CI pipeline. There's optional cloud hosting and commercial support. I'm sure there'll be some reps who'll be happy to talk to you about your supporting needs if that's the direction you'd like to go. It also integrates very well with all your monitoring tools, StatsD, Influx, Grafana Cloud, and now Prometheus and RateMites were announced at this conference. You also get full access to all your data, so you can output a JSON or a CSV file. A good tip is that you can open those up in Jupyter notepads. Grafana is an amazing tool for live monitoring. If you really needed to explore really dense, heavy data, sometimes Jupyter notepads is also a useful tool for going into the detail. So why open source? Open source software is free as in speech. You still have to pay for your infrastructure, but it means you can use as many virtual users as you like for your tests. That's not the case for commercial offerings. It's also extensible, so there's a number of extensions that the community have provided that add extra data sources, extra targets, clients to K6, and hopefully that will continue to grow. There's an active community, and you can avoid vendor lock-in. So I'm sure K6 and Grafana will be amazing partners, but if you've got a thinking long term, it can be very strategically important to avoid lock-in, the same as we do with cloud and monitoring tools. And open source tools have been shown to give very successful outcomes. There's been a DORA report that states that companies that use open source software are more likely to be high performers. So performance. So you think it would be a given that all performance tools have amazing performance. That's not the case. So there's some very popular tools on the market, including Locus and Artillery. If you really need to push through high throughputs, they're not the tool to use. That's not the problem everyone's going to be solving. But K6, you can avoid, complex clustering applications and complex scaling, costly infrastructure by just relying on the performance of the client. CI friendliness. So most open source tools could be stuck in a container and run on your CI pipeline and then get out a result. What makes K6 particularly suitable for it is they provide supported containers. You can get official containers from the Docker repo and run your tests that way and not have to worry about building that yourself. They also have features built into the tool that make it suitable for saying for passed or failed. So they have this capability called thresholds. So you specify the threshold for a test. So obviously, if you're just running a performance test, you're generating hundreds of thousands of requests over a period of time. You don't necessarily want to fail the build just because one of those requests failed or one of those requests is slow. So the K6 solution to that is thresholds, and you can specify that you want 95% of the request to be under a certain time, and then the number of errors to be below a certain percentage. That's the common way that we do SLOs and SLIs in the monitoring world, and it works really well for performance tests as well. My one recommendation with thresholds is often teams are tempted to run a test, see how much latency they have, and set that as your threshold. That's not necessarily what you want to put in your CI build on version control, because it's going to be very sensitive. So if you make any changes, it's going to fail, and you don't necessarily care if your SLA is the request under 500 milliseconds and you happen to be responding within 50 milliseconds and it slips to 60. You don't necessarily care enough to interrupt your development workflow. You might be interested in looking at it later. You might decide that's acceptable growth, and you don't take action until it starts to get towards your target. The alternative is to work out what your acceptance criteria are, your SLIs for production. So say in production, you want to have 95% requests under 500 milliseconds, just set that as your threshold. The builds will keep passing as long as you're underneath that threshold, and you won't have to worry about going back and having to correct it constantly. There's other techniques you can use to watch that long-term drift, and I'll cover that shortly. So let's talk a bit about GitHub Actions, or you could use any tool here. So this would apply equally with a little bit of modification, obviously, for Jenkins or Circle CI, whatever tool you'd be using. But GitHub Actions is a free new resource that GitHub provide. They provide some free compute resource where you can run your builds and your linting. And I thought it'd be interesting to have a play around with that and see if we can run some performance tests there. So this is what the test looks like. It's just a JavaScript file with a default function, and we've called HTTP GET to do the request to the application under test. And we specified 2 thresholds, like we discussed earlier, just to ensure that 95% of response times are under 200 milliseconds, and that the rate of errors is under 0.01%. This is what the workflow looks like in GitHub. So you just drop this YAML file in a special folder in your GitHub project, and GitHub will pick that up and trigger those builds at appropriate time. So there's different types of events you can have in GitHub Actions. So one of them is release, the others are push and pull. You can also do a schedule, so you can write a cron style scheduling and have them trigger based on time. Or there's a kind of a secret event that you can that you can Google for that lets you trigger the builds manually, which is really useful when you're debugging and trying to get things working initially. So in this test, I've pulled in the actual GitHub action. So there's a K6IO action, and that's a reusable bit of code. So in GitHub Actions, there's kind of 2 types of actions. There's a pure JavaScript action that just kind of collects a few commands and gives you a YAML to run that whole block of code. And there's also Docker-based actions. So the K6 one's a Docker-based action. It pulls in the Docker container and executes your K6 test for you. So all you need to do is specify the file name, and the action will take care of putting that container down, doing all the dependency stuff, and getting that test ready to run. So this is what it looks like in GitHub. After you specify the action, it will detect that and trigger it when it's appropriate, and you'll be able to see the workflow and see all the debugging and results in GitHub. You can also store the artifacts, so you can export the results into a JSON or CSV file and attach those for more detailed debugging in future if you want to. There are a few limitations to GitHub Actions that are worth mentioning. So, there's benefits and drawbacks to a free resource. There is a limit as well. Eventually you run out of free compute resources. There's higher limits on the enterprise accounts, but you still have to buy in some extra credit at a certain point. It's also a kind of an unpredictable resource. You don't know who else is using those virtual machines and what the network availability will be. So I found it fairly consistent to a certain point. But I think there's probably a request limit around 50,000 requests. That's the limit that's specified for GitHub Actions as a slightly different product. I couldn't find anything for GitHub Actions, but it seems to be around that sort of limit. There also seems to be a limitation with the action that it can't store artifacts. That might be something that's fixable in future, but that's current state of affairs. There's a workaround, which is just to pull K6 down using a wget and then just to run it as a command. Also, obviously, you're going to be running a test in one location. You don't get a choice where you're running your tests with the with the provided workers. So there's 4 kind of solutions that I'm going to discuss. The first is you can still use GitHub work runners, but when you're running the command, you could just run your application locally. There's not a whole lot of resource on these boxes. They're 2 core boxes, I think about 16 gig of RAM. So it might be enough to start a small Docker container or start a small microservice with Node or Python or something. But you can run that side by side and just execute your tests. And that might be enough, maybe not for a huge load test, but just get the benchmarks to get an idea for what the response time is for each different API endpoint. So just doing a small number of requests to see how long it takes to process that one request. Another option is to do self-hosted runners. So the same as you would in GitHub, you spin up your own workers in your own infrastructure, your data center or on the cloud. Install the worker software and register it with GitHub. You then apply some labels saying it's a performance test. And then you can specify in your workflow that you want to use a worker with a specific label, in this case performance. And you can then give it as much CPU as you want to run a bigger test. Another option is to build your own hosting. So if you've already deployed your Kubernetes app to the cloud, you can just push some K6 workers, because they're Docker containers, you can just push those to another cloud as well, and have those tests run. But then you lose the benefit of the pass-fail, because you won't know if that container's passed or failed, but you will be able to see the results in your monitoring system. And the last option, last but not least, is a K6 offer a commercial offering. So they've got a wonderful cloud offering that will take care of scaling up your tests, geographically distributing them, scaling up as high as you need to go, collecting those results into one user interface, archiving off all the data, collecting trends, and all the problems you would need to solve yourself if you were getting into a kind of more complex use cases. So K6 Cloud looks a bit like this. Like I say, got some very useful graphs and statistics it collects, as well as taking care of scaling up your tests and distributing workers to where they need to be. So I'm not quite done a demo, but we've got an example application that I'm going to walk you through. So the architecture is a bit like this. I've written a Hello World app in Python that I'm going to build in my pipeline and deploy to Kubernetes. I'm also chosen to deploy K6 to a Kubernetes cluster. That's going to write the data out live to, in this case, Influx, but you could also write to K6 Cloud or to Prometheus or Grafana Cloud Metrics. And then I'm going to use the Grafana Cloud to access the dashboard and look at the results. So this is what the dashboard looks like in Grafana. So this is just the dashboard that's provided in the repository. So Grafana provides dashboards, as you know, that can be reused. So I imported the community K6 Grafana dashboard, and that provides a number of useful things. And I've just added to it by making sure that virtual users can be displayed from multiple hosts and add up. And I've made sure that I've got some information about the load that's the resource that's being used by my K6 workers, so I know they're not overloaded, and that's in the bottom right. And then I've got the performance tests, the application under test, the number of instances that are running in Kubernetes, and the CPU that's using, and you can see it's kind of stepping up over time. As the load increases, more instances start up, and the CPU continues to grow as the test continues. So I mentioned earlier that thresholds are a really useful tool, but you don't want to make them too sensitive, because your builds will fail when you don't need them to. So an alternative to kind of look for long-term slowdowns or long-term progression is to take your thresholds, to take some key performance indicators, and to push those back into your data source. And that's what I've done here. So for each test, I summarized the test as a 90th, 95th, 99th percentile, and I've pushed those into Grafana and generated a bar graph. I like the flame view for these. I find it makes it a little bit easier to pick out what's going on. Another useful tip is, until recently, Grafana was kind of limited in that it only showed time series data. So if you're doing builds, if you're not pushing at a kind of consistent pace, that can cause big gaps in your time series graphs if you're trying to look for a trend. So the alternative is now to use the graph plugin, and you can graph by the build number opposed to the time, and that means you don't get a gap between your graphs, and you can more easily compare how one build compares to the previous. So this is what I'd like you to take away from today. Please do try adding performance tests to your CI/CD pipeline. Do make use of the thresholds in K6. Normally you're going to want to consider the error percentage and have a low number of errors. Having 0 might be a little bit too strict, but you want a very low percentage. You're also going to want to set something for latency. So again, a high percentile, 95 and 99% of requests under a certain threshold. But be realistic. Don't set your thresholds to 50 milliseconds if the business would be happy for it to go under 500 milliseconds, because you're just making it more prone to failure than it needs to be. You can always go back and do some optimization later on if the business needs it. Do track for KPIs between tests and plot your trends. So keeping an eye on what goes on in each individual test is really interesting, but it's also interesting to see what goes on over time, and do you have a slow decline as individual features are added. But always validate your tests. It's very easy to think that you ran a really difficult load test and your application's doing millions of requests per second, but actually you've just crashed a box and all the requests are getting rejected. So always do validate your test, make sure your threshold was passed, make sure the application on the test was loaded in the way that you expected, that it was using a sensible amount of resource, and that there wasn't some bottleneck somewhere else in the system like a load balance, so that's just throwing back 500 and you haven't realized. There's 3 resources to get started with. So do take advantages of GitHub Actions from GitHub, and the free monitoring resources from Grafana, the cloud metrics and the dashboards available at a free tier, and there's free trials. K6 also similarly has a free tier of 50 users per second, but also have a free trial available. And yeah, love Grafana and K6, and do bring all your data sources together to make the most of them. Thank you very much for listening. I've got contact information on my website, churchill.me. There's links to the GitHub resources, so there's full examples of all the load tests and GitHub workflows and how to push tests to Kubernetes, if that's something you're interested in doing. So yeah, thank you very much for listening.
Hello and welcome to my talk with title IoT Spy, Telemetry for Security Metrics. My name is Xenia Montruidu. I'm a network automation engineer at Network to Code. What I do in my day job is I automate network flows using Python and Ansible, anything you could do with CLI. We do it with scripts and automation. We are a consulting company, and we also do a lot of telemetry for network traffic. I do have a diverse background between academia and industry, and this talk is inspired by both backgrounds, part of it from security research that I did in industry, and part of it from the telemetry and observability that we do for our clients at Network to Code. So what is this talk about? First, I'm going to start discussing some challenges in IoT security, and then I will give you the solution that we propose for these challenges. And then I will dive deep into the novel metrics that we have introduced for Internet of Things security. Then I will breeze through the implementation for this proof of concept that I'm demonstrating. And then I'm going to go again deep into visualizations and how these work and how these were created, a short demo and a recap. So the challenges in IoT security, these things are exploding in industry and home offices and homes in an exponential way. They're increasing their presence. And at the same time, IoT is a not so mature technology. The perfect example of the security issues is the Mirai botnet. A few years ago, a bunch of IoTs became part of a large botnet. These were mostly web cameras and routers. And the issue was the vulnerable services that they were running, specifically Telnet, and of course the weak passwords that I've got over here. So they became a botnet that targeted DNS and took down big sites like Reddit. It is a problem, IoT security, and definitely a challenge as it's penetrating our industrial networks. On the other hand, security metrics are a challenge as well, because they are about measuring the unknown. There could be 0 days and very unknown adversaries that we cannot predict and much more evaluate. Security is a moving target, and it's also a set of attributes. It's not a single feature in our system, but more than one features. So there is some prior work on this. I have looked at 10 years of academic literature that boils down to quantified security as a weak hypothesis, not as much proof, but a lot of theoretical metrics over there, but not as much robust testing. There's the NIST Common Vulnerability Scoring System that is used a lot in industry, but it's not as granular. It only has high, medium, low type of metrics. And there's also a couple of books that inspired part of this work. So as I have convinced you, hopefully, that these two things are challenges, metrics and security for Internet of Things, I'm suggesting the IoT Spy. A little bit about the name for this solution. At the happy hour at Network to Code, I was voted a spy because of my odd name. So I branded this as IoT spying on us. We're spying on them using TCP dump, which is a fantastic tool in network monitoring because it gives you everything you would like to know about your packet, from the highest level application to the lowest physical and everything in between, data link, transport, and all that. So that's what we're streaming live. And then we are exposing metrics through Grafana, and we're streaming it with a well-known telemetry stack, the T stack. So drilling into the solution now, and specifically the novel metrics, and I will start with a disclaimer that security metrics and telemetry metrics, as the community knows them, such as sensors, IoT sensors and all that, is not the same thing. So security metrics are about reducing uncertainty, whereas a sensor has a very specific value, like temperature or humidity or something along those lines. They're also about probabilities, and they're not as deterministic as telemetry metrics. And finally, they are a set of measurements that could lead to a score, and not as much what you would see as a single measurement in many other observability projects. So the IoT Spy metrics are revolving around this TCP dump that I explained earlier. The first column shows these metrics. Number of inbound and outbound connections can give us a lot of granularity on the communication features. Number of active services maps to ports, open ports, and then packet statistics that we can mine from the TCP dump. All of these correspond to IoT features, and it's a little based on prior work, and all of these also map to security pillars, and that is the third column that I'm showing in this table. So a little bit about these security pillars. Confidentiality is about the need to know, and a perfect example is in industry. Our intellectual property is at a need to know type of basis. Integrity, we care about information accuracy in a bank account transaction. Availability, the most well-known attack to availability is a denial of service. Non-repudiation has to do again with transactions, like you could look at Bitcoin. We want the proof of a transaction transaction and the sender and all that stuff. And then authentication, the most well-known attack would be a man-in-the-middle attack, that a bad actor impersonates a good actor and is mining, taking away information. So how do these metrics map to the TCP dump IoT security metrics? As I'm showing in this slide, there could be unscheduled inbound requests that indicate somebody trying to reach into the IoT in an unsolicited manner and breach confidentiality, mine information. There could be also scanning and brute forcing that can hurt the availability of the web camera or the controller that this IoT is pointing at. And as outbound, also unsolicited calls to home could leak information, private information, and that again maps to security in this IoT metric. So the ports, they are mapped to services, and in combination with weak passwords, which have done some static analysis, they can lead to either confidentiality leaks or integrity, bad data coming out of your IoTs, availability, taking this down, or even safety, because think about an IoT that is a robotic arm and could start acting roguely. Finally, the packet statistics are the most natural metric that we think when we think security, because they are monitored by intrusion detection systems, and they point to availability. If you have very high inter-arrival rates or very large packets, then that could indicate that you have loss of availability and timely services. Breezing through the implementation, as I said, we are collecting TCP dump data using a remote connection from a workstation to a wireless access point and monitoring a specific wireless interface. That's why this is called SSH dump in the figure. And then a Python script is running in the server workstation, and it's doing all the streaming of that SSH dump. The streaming is done using structured JSON data, and the data is enriched with metadata and then outputted in an influx line protocol. And then finally, the Telegraph agent is using input tail plugins to get the data and outputs the data to the influx time series database. So very quick, the implementation also includes the data model, which revolves around tags for filtering, and they're selected by the metadata, as you can see in the slide, and also by continuous fields for calculations, mainly in this case, the inter-arrival and the length. And this data model is chosen for the lowest cardinality that we can get as possible. Finally, as I said, I'm going to dive deep into those visualizations. So the visualizations, the heart of the visualization is the time series. And Grafana can visualize really nicely those time series and show us patterns and all of these things. Now, there's also on the left and right some additional visualizations that are helpful for the IoTs, probability plots and cumulative distribution functions. And on the other hand, histograms and tables, pivot tables. And all of these as a whole revolve around the framework that we call exploratory data analysis. So the data scientists in the crowd probably have heard of this before, and exploratory data analysis is a NIST framework that revolves around visualizing data to uncover the patterns, and then also extracting variables and finding anomalies. In this case, the time series and the histograms are showing patterns. The tables can show variables, and they correspond to parts of the framework, as I'm showing in the slide. And then the probability graphs on the left side are these probabilities and cumulative distribution functions. Now, the probabilistic visualizations are the visualizations that I needed to be creative on, and that's why I wanted to show a little bit what's happening here. Here I'm showing an example of calculating the probability of a port being hit by the outside, and this could be a port like a telnet port that is getting hit quite often. So the first query shows for a specific port and a specific device IoT destination, the number of the count of outcomes, and then the second query shows all the possible ports that could be hit for this specific device. So dividing those two leads us to a probability that this specific port, let's say telnet, for a web camera could be targeted in an amount of time, which is 1 day. So to divide or do any calculations between time series, bear in mind that they have to be of the same size, or then you may have to do some shifting and manipulations like that. In this case, I group by 1 day, so I bring them to the same size. And that's a result of this visualization. The next part is the cumulative distribution. And here I'm gonna show a specific point as an example. In this case, this to me indicates that there is a 20% probability that I have an inter-arrival rate for the smart light between 0 and 0.06 time units, which can be milliseconds in our case. So in this case, the cumulative distribution function gives me a range for the probability values and yet another point of view for this security metric. The histogram is a really nice visualization default in core Grafana, and that can give us the patterns of the data and distributions. And in this case, we can see normal distributions could be fit into that histogram of the Amazon Echo port destinations. Finally, the tables are something that we don't think too much in time series, but they can be a really nice metadata point that can show, that can help us drill into those services in this case that I'm showing and find if a service is a rogue service or a legit service like a firmware update or something along those lines. So before I get to the demo, I'm gonna say a little bit about what devices you're gonna see in this demo. The proof of concept that I have has a couple of smart devices like a smart light, a smart plug. Then it has phones, printers, things you could find in an office, bring your own device type of things, web cameras, and then Echo, a home assistant. So the demo, I'm going through first my dashboard list, which has some summary graphs. One of those is about the inbound and outbound call summary. And this one is nice because it focuses on the source and destination devices, inbound and outbound calls, as I said. And you can do some groupings, like let's say I'm interested in comparing the Echo to the printer, and there's an order of magnitude between those two, the difference of the outbound calls. And the outbound calls, if I remind you, are about calling home. Also, you can see the gauges here that can show us a more aggregate number. And then in the second part, I'm going to show the inbound calls. And in this case, I'm not choosing the printer because it's not getting calls from home. However, the Echo and the camera are getting a lot of regular calls from home, actually considerable ones. And then I have a summary of the pivot tables for the ports that are being targeted, and that can give a wealth of information of what is being targeted in terms of services like HTTP, DNS or Telnet or anything else. Now back to the summary statistics. The packet statistics are a different point of view because this data is continuous, and therefore we can use the CDFs for this kind of data. And actually, if we increase a little bit to 24 hours, we can see a little bit more interesting smart light type of inbound requests. Now I will emphasize here in all the graphs that I'm showing, the IoT testbed is not being used. So these are unsolicited calls or calls for maintenance or asking for updates and stuff like that. So that's important for a security profile to see that there's a lot of unsolicited inbound and outbound calls, and the CDFs that we have discussed that are showing the ranges of probabilities. And similarly here, and as you can see, we can also use these continuous data for alerting, which is a really nice thing. Here I have alerts for the length, and I also have alerts for inter-arrivals. The last summary is the services summary. And that one indicates really nicely the ports, and we can have multiple tables. Again, for uniformity, I'm going to use the same example. And here we can have multiple tables that we can compare and multiple statistics. And definitely the highlight here is the histogram that shows the distribution, something like a long tail distribution for the echo and a more normal distribution for the camera. And of course, the outbound called by IoTs or open ports for the IoTs and stuff like that. Lastly, a detailed graph, and I'm not going to show both, just the inbound, so these unsolicited calls. And this one is nice because it focuses on ports. So if I take the most popular port, I can put it next to this other one, and I can see that the difference in the time series and do my comparisons and all that good stuff. But the meat of this is the probability of accessing a port, and that's what's really nice. I can have more than one port and select them and do my comparisons very nicely and make my security scores. Okay, so good, bad, ugly in these graphs. Like I said, unsolicited calls, a test bed that is sitting there and is making outgoing calls. And as you can see, the echo doubled the amount than the camera. These are interesting things to make your scores, alerts, and all of these things that connect to the IoT security. Here, the timeline that I'm showing is the camera is being used actually to detect something, but the echo is spiking without being connected to the camera in any way whatsoever. And here the corresponding incoming calls. Now, a nice thing is the difference between the inter-arrivals for a light and an Amazon Echo. And as you can see, there is a difference. 70% of these inter-arrivals can be pretty high, but the light is doing little small spurs and smaller inter-arrival rates. And then these bursty graphs are really helpful. That's at midnight, a port that's being used, and it may be a scanned port from an outside, and it indicates, it can point to some alerting or some unsecure service running in that specific device. The funny thing is that this port, when we calculate the probability for a day, is the probability is almost zero because it's very, very low. So accuracy here is important. So if you want some additional accuracy, you will need some additional decimals. Okay, so at the recap of this talk, I presented some novel security metrics and some novel visualizations using probability. I also used the TIG stack for visualization, storage, and alerting. And the future work is about using better anomaly detection with these metrics and using z-scores. That's going to be a very interesting metric because they show deviation of one data point from the mean, but also another part of the future work is going to be generalize the implementation to a Telegraph plugin and offer open source to the community, which is something that we really like to do at Network to Code. So thank you for your time and for attending my talk, and I am looking forward to your questions. Hello, everyone. I have a couple of questions that have come in. The first question is, can you share a little bit more about your work in academia? So that's a fun question. I could talk for hours. Started with performance modeling for computer networks. This was This was the topic of my PhD, and that's where the telemetry goes in. I always wanted to find bottlenecks and things like that. But when I did my PhD, I didn't use Grafana. And then moved on to computer network security. This was something that I always wanted to do. So I did, one of my favorite things was to set up a lab, and as I did in my home also, with vulnerable things. I love doing CTFs, capture the flag competitions with students, and finding, little bugs in these things. That was part of the work that I did. I also did some work in intrusion detection, which also makes me a little bit of a data scientist, but I don't really consider myself a data scientist, although I really enjoy those algorithms and stuff. The UX question is very interesting, and it's a tough one because I'm not a very good UX person. So it says, do you have tips on how to show real data versus predicted data on the same graphs to compare? So this is a difficult one because if the data is close, then you have a good prediction, but then you can't really show. There could be bars. I've seen, bars that show the difference because you don't want to just show the difference between, let's say, your diagrams with just different colors and all that. So something to show the difference between predicted, like error graphs would be great. And I see one last question: is this feature Terraform integrated? Not yet. However, yes, that can be future extensions. Thank you so much for the great questions.
Hello everybody, and thank you so much for joining us here at ObservabilityCon 2021 for our presentation on learning the tricks of Loki, distributed logging at scale. Before we dive into the presentation, a bit more about ourselves.
Hi there, my name is Alex Jones. I'm a principal engineer here at Civo Cloud. I'm also the tech lead for the CNCF group called Application Delivery, and I help to maintain projects, perform due diligence, and to help folks get into the sandbox.
My name is Anais Urlis. I'm a site reliability engineer at Civo. Before joining Civo, I worked for several years as developer advocate, first in the blockchain space, and then in the cloud native ecosystem. I'm also a CNCF ambassador. Now, within our presentation, when we're talking about our learnings and our use of Loki, what are we actually basing our experience on? We both work at Civo. Now, what is Civo? Civo is a Kubernetes service provider, meaning you can launch Kubernetes clusters in 90 seconds or less. It's based on a Kubernetes distribution called K3s. We have highly transparent pricing that is competitive across the market, and we are cloud native first, meaning when you spin up your Kubernetes cluster, you can select the cloud native projects and tools that you want to spin up on your cluster alongside it. So within 90 seconds, you can have a Kubernetes cluster with your entire observability stack already running on top of it. Now, this slide is taken from our KubeCon presentation that we just had a few weeks ago. We have in several regions our stack, our compute stack, and on those stack, there are 32 compute nodes, of which 4 are the control plane. And on the rest, we run our workloads. So all of our tenant clusters are basically running within a super cluster. Now, as you can imagine, running this highly dynamic infrastructure, we need a lot of different observability tools installed to actually know what's going on in those different regions on those different compute nodes. Now, here's a little bit more on our agenda, on how we structured our presentation. First, we will give a little bit of an overview to what Loki is, what's the infrastructure, and what are the different components that we need to use alongside Loki. Then we have a demo for you on how you can get started with Loki. And then we provide an overview of the tricks of Loki based on the past months of us using Loki at scale. So why do we want to use Loki in the first place? Well, traditional logging solutions are no longer fit for purpose. With our infrastructure and our application deployment getting more complex and more distributed, we need our logging solution, our entire observability stack to scale up with our needs. However, traditional logging solutions are first of all expensive. They don't integrate often with our existing observability stack. They are difficult to operate at scale, meaning they are difficult to operate in a distributed environment. And then lastly, they are challenging to correlate against your existing metrics. If they don't integrate in your existing observability stack, you will have to make the connection manually a lot of times. So here's where Loki comes in. Ultimately, our goal is that we want to use a cost-effective way to collect, store, and query our logs. Now, Loki is a highly available, horizontally scalable, multi-tenant log aggregation system. Now, you don't have to remember anything of those words in the slide, just that Loki equals log aggregation for you to store, access, and manage those logs. The benefits of Loki is that it's cost-effective. It integrates into your existing tooling and your existing observability stack. So, for example, if you're already using Grafana Cloud, you can just use Loki alongside it. Also, it scales with your existing infrastructure. You can run Loki either as a single binary in a distributed environment or as part of Grafana Cloud. Now, here's a high-level overview on what actually happens. What's the process between your logs getting generated and then you accessing those logs in your Grafana dashboards? Well, there's an additional component. In our case, we use Promptail to access those logs, to basically gather those logs from, for example, from within your Kubernetes cluster. So wherever Promptail runs, it will scrape those logs and gather them and forward them over to Loki, and then you can access those logs within Grafana. Now, you can use, instead of Promptail, you can use also other tools, other components instead of Promptail. We use Promptail at Cevo, so that's why our presentation will focus on Promptail specifically. Now, a bit more about Promptail. Promptail is the part that is used to discover logs, process logs, and ship those process logs to Loki. You basically set scrape targets for Promptail of where it's supposed to get the logs from. It's highly similar to how you would set scrape targets for Prometheus. Here's a more detailed overview of our different components. So we have Promptail running within our different clusters, within our different environments. Now, the Promptail will gather those logs that are generated either from our infrastructure or our application, and then forward those logs to a component called the distributor. The distributor, the ingester, the query, and the query frontend are all part of our Loki stack. Now, the query frontend is optional. Once we have those logs and we send them over to the distributor is then responsible to make sure that those logs are actually valid, that they fit our requirements that we set up. Now, then the distributor will send those logs to usually three different ingesters. And the ingester is responsible to pack up those logs into chunks. Now, once either the chunks are full, meaning they reach the maximum number of logs that they can hold, or a certain amount of time has passed without the ingester receiving any logs, or it hitting a specific timeline, it will send those logs over to our long-term storage solution, whether that's an S3 bucket, DynamoDB, or another solution that we are using, that we're integrating with. Now, the good thing is about these chunks that they basically allow us to only store the minimum amount of information needed from those logs. So for instance, we don't store, or Loki doesn't gather the timestamp of every log, but only the timestamp of the first log in the chunk and the last one. And then within the chunk, all the logs are ordered by timeline of when they were received. And that allows Loki to query the specific time frame of the logs later on without actually needing access to the specific timestamp. Now, when we want to query our logs, we use the querier, and the querier is used to access the Loki API. The querier will pull out the logs either from the ingester, if they are still an ingester, or our long-term storage solution, and then make them accessible to the query frontend. The query frontend is optional. It can be used to optimize your use of Loki, but you don't have to use it.
How do we use Loki? Well, I'd like to show you a little bit more about how Civo has implemented Loki in this simplified diagram. As Anais mentioned prior to this, we heavily depend on Promtail for retrieving our scrape targets. And one of the things that we do that I think is fairly interesting is because we run bare metal superclusters, we have access to a lot of the journal and underlying logs that are particularly interesting, whether that's from the kubelet, whether that's from CAdvisor or some other service. And so therefore we use syslog-ng to forward the logs into Promtail in the same manner as we would pull logs from the container path on the host from Kubernetes. This means that Promtail is aggregating not only the system logs, but also the application logs. And as Anais took us through a moment ago, we push that through the distributed gateway, the ingester, and object store. One of the things that I will come to talk about a little bit later is some of the optimizations around this. But the exciting part for us is that we have a single pane of glass for our SRE experience where we can combine not only our log experience, but also our tracing and our metrics. Now I'd like to take you through a demo on a simplified example of Loki, where hopefully we can talk through the fundamentals of Promtail, Loki, and Grafana within a Civo cluster. So now it's time to jump into the demo. The first thing I'm going to do is spin up a cluster. We're going to take a look at the code while this cluster is starting up. This is a Civo cluster. Should take about a minute 40, a minute 50 to start up. I've got a simple repository, which I'll share in the links that accompany the slides. What's effectively happening here is we have a very simple set of commands of create myself a new cluster and install the necessary stack to run on top of that. You can see here that we have Grafana, Promtail, and Loki in a distributed manner being set up. And the last thing I'm doing is grabbing the secret out of Grafana. There's no more secret source. And I think you'll be suitably impressed that when we get this set up, it just works. I have two resources in terms of a config map and a prom values file. And to talk you through each one, the config map is simply so that Grafana knows where Loki lives in the cluster. And you can see it's a single line telling it that Loki lives at this service address. And secondarily to that, we have a Promtails file. And all this has inside of it is where is the gateway for Promtail to push to Loki. So when we think about this sort of stuff, I think it's important to visualize it. What we're going to try and set up today is effectively a Civo cluster, which is a K3s cluster. In this cluster, we're going to set up an observability namespace. And in that observability namespace, we have three distinct components that are going to work together to provide us cluster level logging. So we have Promtail, which will be installed as a daemon set. We have Grafana, which will be installed as a deployment. And we're doing the full Loki distributed architecture, which will give us the 4 or 5 named components from previously in the slide. So we'll have key features such as the querier, the distributor, the ingester, etc. So let's now go ahead and install this stuff. So you can see the clusters come up in a minute 40 seconds. And now what's exciting is we're starting to install things into this cluster. I showed you in the illustration before that we have 2 YAML files. And those YAML files are simply for telling things where everything is. So if I was to describe it like this, you would effectively have 2 arrows, one from Grafana down to point where to Loki is, and one from Promtail to say where it should forward to Loki. The kind of data we're going to show in this example here is going to be fairly straightforward. Each Civo cluster has what is called a Civo CSI controller. Now, the CSI controller is an interesting project because it will often throw some interesting debug messages whilst it's spinning up. And so what we can do is we can focus on those kind of messages. Secondarily, in your own clusters, what you might find is a useful thing to take a look at when you've installed Loki for the first time is the kube system namespace. Because in kube system, that's where you get to see a lot of these components working together. You can also see errors in the kube system namespace when you've installed something, it's not quite worked, if a pod has gone down or a pod is spinning up at the same time. So let's slide over to the next screen here and take a look at what's going on in our cluster. First things first is I described that you can see Grafana is being installed. The only thing I've had to do in this installation is to turn on my data sources sidecar. What that's done is it's enabled me to give it the config map, and the config map that's described where this Loki deployment is being read. That's it, really. So it knows where to get that Loki address from. And we do this in our superclusters in the same way. We actually try and do as much of this as in code rather than any kind of hand tailoring or hand cranking. And this is thanks to a lot of the work that's gone into making the CRDs within Grafana native, so that you don't have to have any of that within the UX. Particularly at large scale organizations, when you might have hundreds of alerts, those can all now be codified in config maps as either Grafana data sources, Grafana dashboards, alerts, or additional config. So when we start to have a look at this, let's open up a new tab, and I'll show you just how easy it is for us to go into the code base from Civo. So I have my simple makefile. I'm going to jump into my cluster, and let's see what's going on. As we grab our config, let's check our nodes. That's the first thing we usually check. So we can see I've got our cluster running. And what we should see on our cluster is that we have our various components installing. You can see Grafana is installed. I will just go ahead and do an installation on Loki so we can see how it works. We'll get Promtail installed. I think this is more interactive. I can do it this way. So you can see Promtail is now installing. When Promtail is installed, we can then put Loki in. And you can see here, we've got Promtail successfully creating the pods. Once those pods go live, you can see that we can put Loki in place. Now it's the last command, Helm upgrade install Loki. So this is nice that you can see that this is exactly how we'd run it in our production clusters. We might have a little bit more config, but ultimately it's something along these lines. So I've now got all of my components installed. As you can see at the bottom here, this is a list of the things that are going into that Loki set of concerns. So everything's now spun up on the cluster. As I mentioned in the Grafana config maps, we have that data sources, and this is just for me to sidestep having to set it up manually. Comes out of the box. So let's take a look at things. I think we're pretty much there. I'm going to grab the password for Grafana, and I'm going to open it up in the browser. I'm going to port forward. This is a very helpful thing to do. Let's grab that. I'm going to put in my admin password. I've logged in. Now, what you should be able to see is that the data source is pre-configured, and this is fantastic. And one thing that's also worth mentioning at this point is that you can use the derived fields annotation to create links from the values and messages. And this is really useful because we can start to pull out fields that are nested inside of JSON structures and other objects. So that's pretty straightforward. We've got our data sources from Loki. Now, what you can see is that Loki in the Explore is set up. Now, this tab here already is giving me the option. You can see that labels have been pulled out of log messages that are being sent through the cluster. Now, I mentioned that Civo job, didn't I? I mentioned the CSI controller. So we can see here that CSI controller, and I can show logs from my CSI controller. I can see that there's some debug messages, some interesting stuff that's happened. You can see that there's some gRPC setup configuration. Now, again, if I want to look at some of the more interesting stuff, I could say, well, what about errors, right? What's happened here? I wouldn't really anticipate any errors at this point in time. So we could pick something that might throw a few more errors, like the kube system namespace. There are always typically a couple of errors when Kubernetes is setting up, whether that's a metric not being sent or it's waiting for something else. So, you know, equally, it's super easy for me to just do a check on error. However, more realistically, what could be useful is for me to look at errors over time to see, is my cluster getting worse or is it getting better? So let's run that query. And we can see that we're getting effectively data back from a few of these different apps. So I could even wrap this in an average. And that average will then tell me, hey, what's going on over time? So that could be a cool thing to show. So what we can do is we can do an average of errors over time. And I'll put the average on the wrong side. I'm sorry about that. There we go. And we can put that there. And we can see the average number of errors over time. And you can see how much effort I put into this, right? This is a couple minutes. And already, this is kind of useful. You know, the XY might need to be tuned, but I can take this right here. I can make a new dashboard. And within 10 minutes, I'm adding value to my team because I can show them, hey, I'm getting data from our logs that show the average number of errors in our logs are increasing over time. And as I said, within a few minutes, I can save this as a very basic example, and we can have that up on our screen in the office, driven by logs from Loki. I hope that this demo has showed you that effectively you can get going with the bare bones of this makefile, right? You need Grafana, Loki, Promptel, and you're already able to pull out value. And as an SRE leader and somebody that works with this stuff every day, it's absolutely invaluable. Let's talk about the tricks of Loki. And these are our collective experiences from working with Loki at Civo over the past few months. First and foremost, Loki can be configured to suit your infrastructure needs. It's flexible and scalable, and there are multiple components that can be dropped in and pulled out as need be. As you can see on this slide, I've assimilated this into three primary pillars. You have scaling. So the distributor component, as we know from the earlier slide, can be scaled out. Query front end can be scaled out as well, if need be, to have more pods to return requests. And equally, the querier can be scaled out. It's also important to know that when you are scaling these components out, you also have the ability to add additional caching layers. And memcache being supported is incredibly useful, especially when you're performing very, very repetitive queries that otherwise would be incurring a latency penalty every single time you query them. And an example of this might be if you build a dashboard from your logs and are using an expression on that log so that you can find some information to show the team, that would actually be hitting the querier multiple times. Whereas if we're using the caching mechanism, that actually will sidestep and get the cached result. The third piece that is particularly useful for us is being able to change the KV store. So we have the index store, but we also have KV stores, both of which have a variety of options. I've listed a few here that are particularly useful for our environment, which is native S3, using GCS, or even Cassandra as your backing store. And these options provide a lot of flexibility on where you ship your logs. For example, if you're an on-premises solution, you might want to use Cassandra because you can stand that up yourself and you won't incur transfer fees. Combining Loki with Tempo to extract traces from your logs is one of the most powerful and exciting features that we have the ability to leverage in our observability stack. What's so exciting about this is that you can pull out trace IDs from your logs, and in the Explore for Tempo, you can see them right there and have a side-by-side view. I mentioned earlier this idea of a single pane of glass. Well, it's really epitomized by being able to work with these two different types of tools within Grafana and interchangeably pull out the data that you need. And this is a super exciting experience as an SRE. Labels are powerful shortcuts to your logs. If you're writing structured logging solutions and you have a standard set of labels and fields, you can really gain the benefit of seeing these within Loki by being able to quickly drag and drop into those labels to find out the information you need. As you can see in this example, if I want to see what's going on with Civo's CSI controller, I know that the app label exists and we've labeled that in the manifest for that controller, and we can pull that straight out. And that's a batteries included solution. We've not really had to do much additional work there to make that happen. What I particularly like as well is that we can then pipe it into a particular type of stream output. So we have a choice of looking at the standard output, the standard error, or the combined stream. And this, again, is particularly useful when you're starting to make dashboards, you're starting to leverage some of the next features that I'll talk about in Loki. LogQL. I touched upon the idea of looking into your logs, but LogQL syntax, very closely following PromQL, takes your querying to the next level. The built-in functions that come with PromQL and LogQL are very similar. So averaging, rate, and other commands are all there for you to use. In this example, you can see I took that CSI controller error rate and I've started to look at it over time. And this is extremely exciting because you can start to build out dashboards. You can start to pull out useful information directly from your logs. And this is something that was an extremely tedious task, or it had to require a lot of chaining of filters and expressions. And it's done in this extremely concise and succinct way. And probably the last but the most impactful tip that I have for Loki is that you can use Loki to create dashboards. And I've mentioned this a few times now, but you really only start to understand the power of what you can do when you start using the Explore feature, taking an expression, putting that into a dashboard. You are effectively falling into a pit of success. And as you can see from this example, this has come from one of our test clusters. It is extremely powerful to see how many errors you're getting across the board. Now, this is a broad net, but it's a signal that's useful because you can start to see that if the errors spike from 0.1 to 43%, you know you've got a problem. And as you can see in the live logs there, it is so easy to find out where that's coming from. And again, if you're leveraging other tools like Tempo, or if you're combining Prometheus metrics into your Grafana solution, you have a one-stop shop for being able to start to diagnose, triage, and remediate these issues. So what's next for Civo? What are we doing with our observability stack? Where are we taking our solutions in the future? Well, it comes down to 3 primary tasks for us to achieve by the end of 2021. Inter-regional logging is a big next step for us. We've got fantastic logging at the supercluster level with Loki. We're going to take that further and start to use Promtail across our regions to aggregate logs from Frankfurt, from New York, from London. We want to be able to see that if we apply an update to a supercluster control plane and there's a different version of Kubernetes, is that reflected in the amount of errors that we're seeing? Is there a drop in errors? Is there an increase? Can we compare that against other clusters? And using some of the powerful expressions that we showed earlier on through Loki and LogQL, we can do that in such a simple way. And with external labels being applied, it means that we can select and know where those logs came from. The second really important part of our goal this year is for supply chain security. And as part of the security element, we need the observability. So it's great to have something like Aquasec, Falco, Sneaker, any of these solutions to look at your images, look at your running pods and containers. But if you're not actually alerting on that, it's really difficult. And the alerts sometimes can be difficult to manage, difficult to write in Prometheus rules. And so therefore, again, we can take a simple sentence in Loki, and I can use that sentence. If that appears, that can trigger my alert, especially with Grafana alerts. So it's a really fantastic hand-in-hand solution for writing simplified alerts, especially around the supply chain observability. And the last thing that we're doing that's particularly exciting is adding additional synthetic monitoring into our tenant clusters. So I mentioned having application logs. I mentioned having the logs from the bare metal clusters. But what about we could actually pull the logs out from our tenant cluster nodes, and they could tell us, is there a problem far ahead of the Kubernetes API on the supercluster registering if a node has gone offline? Imagine if a tenant node runs out of disk space, Loki would tell us ahead of time before Kubernetes API flagged after 5 minutes that that node had gone down. So that's really what we're trying to do, is to really leverage that to the next level so that we can start to really get ahead of the curve so that we know about problems before they become problems.
So summarizing, in this presentation, we showed you what Loki actually is. What are the different components that go into setting up Loki? And how would you get started using Loki and make the best out of it? And then we went over our key takeaways, our main learnings from throughout the past months in our tricks for Loki. Now we have some time for Q&A, so we're going to join in just a second. Thank you so much for joining our presentation. And you can find us here with those Twitter handles on Twitter if you have any further questions.
Hello there.
Hello, everybody. Awesome. Thank you so much for joining. We have 4 questions right now. I'm just going to go ahead and read them one by one, and you can answer, Alex. So the first one is, what are your retention policies around your production infrastructure logs?
So we generate approximately 2 terabytes of logs a week from our production clusters. And so we retain them for approximately 14 days. And anything over that, we look to put into cold storage. At certain companies, there are compliance reasons, such as SOC 2, ISO 127001, where you have to retain production logs for 365 days. And bearing that in mind, having a strategy for cold storage is really good. But yeah, typically speaking, it would be about 14 days, because any more than that, we find that it's an immense amount of storage cost on our object storage.
Okay, next question. How many Loki deployments are currently running at Civo?
That's a really interesting question. So at the supercluster level, it's a one-to-one cardinality. So we're running 3 different regions right now, with I think a 4th coming up quite soon. So that would be 3 primary Loki distributions. Those distributions are tuned so that we would have between 3 and 5 ingesters, a multitude of queryers, several memcache deployments as well. So they typically look fairly homogeneous. However, we will tune them based on the throughput as well.
We have right now 4 more questions. The next one is, does Loki ingest all the logs, and or is there the ability to choose which logs to ingest versus index? And then thinking about comparison between Loki versus Datadog, Splunk, Elastic. What is the difference?
Yeah, that's a really interesting question. And I skipped it a little bit in the presentation, but you have separate data stores for the indexes versus the actual chunks of Loki. And so, yes, you can index logs, and you can isolate to a degree. However, there's a little bit of post-processing you need to do for that. In terms of, can you select the logs? Yes, this is one of the nice things, is that you use scrape configs. You can add annotations and labels to those logs as well. So I can simply select a log path, such as the Kubernetes audit log that would be available on a node or on a cluster, and then Promtail will go off and grab that. Something else that Promtail uses that's really interesting is the fs notifier and file watch commands at the operating system level, so that it can then pick out the latest changes from those files as well. So really think of it more of as an active tail.
Next question. We mentioned Tempo in combination with Loki. Are we currently using Tempo, and what's the process of getting them both linked together? And could we share any data points around trace volumes?
So we are actually using we're using Grafana for our UX. We're using Loki for our logging solution, and we're using Jaeger tracing in our production environments. However, we're very keen to migrate to Tempo. Tempo has gone through a graduation recently, and there's a whole slew of new features that we're excited to integrate. One of which is the searchability of Tempo logs, which wasn't actually something we could use previously. And as soon as we've got that update, we'll get it in place. In terms of trace volume, our traces are actually being emitted from our operators. And in Civo, we have between, I think it's 5 and 8 primary operators that manage our clusters. So those will create custom resource definitions, and they will then provision tenant clusters. And so those operators are creating between, I'd say, 1 and 5 RPS. So 1 and 5 requests per second, 1 and 5 spans per second, which is a fairly low volume. But what's interesting is that we're looking through reconciliation loops. And so the nesting of those traces goes quite deep. So the spans will go to quite a deep level of perhaps sort of 20 or 30 functions. I hope that answers the question.
Just heads up, there are a lot more questions, so maybe we can keep it shorter.
Sorry, yeah, I'll try and do a quick fire. Yeah, of course.
Okay. Are there any limitations storing and retaining logs?
Yes, it's expensive. It's expensive. Storing any kind of data set like logs is very expensive. However, Loki is probably the most cost-effective option I've seen so far. And I've worked with things like Splunk and other large-scale solutions. So it's a cost.
The next question is around the use of Prometheus. Now that we have Loki, we can have metric-like visualization plus alerting with Grafana. And then where does Prometheus fit into the mix of our...
Yeah, so logs are fantastic, but they're not the be-all and end-all, because you don't emit metric or quantitative. All quantitative data doesn't come into a log, right? And logs are only as powerful or as useful as the person that implements them. So if the log isn't structured and it doesn't actually have, like a printf on the CPU use, you're not going to get that in the log. And so Prometheus still has its place as something that can effectively aggregate metrics that come in conjunction with logs. So I see them as complementary. They're not either or, right? I hope that answers the question.
Can cold storage logs be queried with Loki? So once you move your logs to cold storage after, like, I guess,
I mean,
week or so.
definitively what is cold storage? It's just transfer that is more expensive. I think you're probably talking specifically about AWS Glacier, and I couldn't give you an opinion. I don't want to say the wrong thing. We typically wouldn't access directly cold storage logs, so I'll refrain from making a comment on it. But yeah, cold storage is going to be, in a hyperscaler point of view, that's going to be higher transfer fee logs. It's not that they cannot be physically accessed. It's just that would you want to access them directly?
Next question is, I noticed no mention of a compactor component. I'm guessing custom retention featured in Loki 2.3. Is it not used at the moment?
That's a really interesting question. So we don't typically use the compactor in our configuration, and that is not for lack of wanting to use it. We use a compactor for our metrics. We use Thanos that does metric compaction. We don't use it for logging compaction purely because of our capacity to test these components out and take them to production. One of the things I was showing in the demo is the distributed Loki microservice configuration out of the box was extremely persuasive in being like, let's get up and running. All of the additional components, such as mem caching and everything else, we've had to go through and assess. But yeah, as Loki matures, as we come along, we'll start looking at other components such as compactor. And as my previous comment around log costs, this sort of stuff could really help us out.
Next question is, have you tested Cassandra versus Memcache for caching performance?
That's a really good question. Typically, Memcache will have a higher performance than Cassandra, and there's some prior art to that. I can't give you figures right now. Cassandra, though, would beat Memcache in durability because of the replication mechanisms within Cassandra. So it's a trade-off, right? Memcache will give you a lower latency, but Cassandra gives you a higher durability and reliability. So there's a trade-off there.
Are you dealing with multi-tenancy? If so, how?
Yeah, so that's interesting. So our logging from Loki is for the supercluster. Our tenants, our customers, live inside that supercluster, inside of isolated virtual machines, and we do not scrape their logs, right? So we're not looking at the kubelet logs inside of the tenant clusters. If we were to do so, and I've entertained the idea, it would involve a vast level of relabeling, because you would need to make the logs relevant and searchable. So you would effectively need something like Promtail with a relabeling mechanism at the individual level. But no, to answer your question, we don't do that at the moment. We just look at the supercluster logs.
Have you experimented with recording rules in Loki?
No, we haven't really looked at that at all, to be honest.
And the last question is, what tool have you used for the graphics?
Oh, that's Excalidraw. And I think I need to start taking royalties on how much I use those in conference talks. Although, did we use Excalidraw or did we use the Grafana template?
So we partially used Excalidraw. We partially used the Grafana templates that were provided to us.
Kudos to the team. Yeah, the great graphics.
Kudos to this amazing template. Exactly. That made it really easy to make it look good. Yeah, and that's it. That's all the questions that we got. Awesome. Thank you so much for joining.
Thank you, everybody.